Hello. I have returned. Is there anybody there? F5? Any F5s in the chat? Yo, not ears. Thanks for the follow. Alright, he's back. Yeah, hopefully it doesn't cut out again. That would be really, really annoying. That would be quite annoying. Jerry, hello! Got a question about decals. Is it possible to make a decal appear only on specific meshes, given that I still want other meshes to still get other decals? Yes, there is a way. I will be making a video about it in the future at some point. The gist of it is that you can... you know, I won't do this in this folder. Let me do this in content, dump, Niagara videos, whatever. You can use the custom depth pass in a decal. We've got deferred decal, blah, 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 it needs to be translucent, whatever. So you can go, fuck, what's it called? Scene texture. Scene texture. So like the post-process, you know, input. Here's the scene depth, custom stencil, and world normal. There we go. So you can go scene, well, custom depth. You can also get the stencil pass. Stencil. Where the fuck is the stencil? Right, there used to be a decal mask, but now it's been moved to stencil. Yeah. Fuck, where is it? Is it? Wait. No, what the fucking... It dropped again? Oh, wait, no, that might just be my internet that time. Let me change my bitrate. Low quality. We're going 10 by 10 pixels. Alright, we're down at 2K. So if it drops after this... It could also be if you're using low latency mode. But that would only be like for stuttering. You know? Not for the actual stream fucking restarting. Here it is, custom stencil. Custom depth, custom stencil, and then also scene depth. Bam. So you would essentially use these three dudes to okay, yeah, what the fuck's going on with Twitch? It's fine going to YouTube. Let me just log in to restream on the internet. Yeah, it says session 0. Viewers 0. That doesn't make sense. This is fucking annoying. It says it's streaming to Twitch. 2 of 2 active. Yeah. Seems fine currently. Okay, maybe we'll just run with this. I'll keep an eye on it. I can have the streamer. Really gonna kill my internet though, but yeah, I don't know. I don't know. Let me just look up restream Twitch. Twitch stream. Dropping out. Yeah, maybe it's just my bandwidth. All right. Anyway, continuing on. I think we're back. I think we're good. I think everything is fine. I think it's all alive. Maybe it was my internet. Anyway, so we're talking about decals. You can use custom stencil, custom depth, and scene depth to, well, not for specific. No, it is for specific meshes. Yeah, because meshes for a given mesh, you know, this wall, you can say custom depth, render custom depth pass, and stencil value, you know, 4 or whatever. And so you can tell a decal to, I think, 1 if the float aligns with the stencil buffer value, 0 if it does not. And so this would be, well, mask this guy, R channel. I think you divide it by 255 or some shit. Maybe it's 256. And that should give you the thing. Well, no, you do. Fuck, I can't remember. What does that even mean? ID scalar. Oh, this just gives you the custom stencil, does the if below, blah, blah, blah. Okay. Okay, so you just say stencil mask at stencil value 3. Bam. So if we did something like this, where it's like, okay, yeah, like the opacity, or you'd multiply the opacity by this. So maybe you've got like a texture, you know, you got this guy is going into the base color, and then the alpha is going into the opacity, but then you multiply it by this stencil value. And so, if we grab this guy, splat him down there. Where the fuck is the widget? There it is. So, if I didn't have that stencil going on, we would have this. So we can see ugly man face. Let's just go unlit mode. We've got ugly man with a huge Megamind forehead. But then if we multiply it by the stencil mask compare, then it's gone. But if I tell this wall, render to custom depth, and you are number 3, then it will get the, you know, the decal. But you can see that it's kind of giga-fucked because you can see it through other shit, right? Which you don't want, probably. So you would need to something scene depth something. Let me just get a mask. You pretty much want to subtract one of these from the other one with like a little offset, like a little safety offset. I wonder if there's like a function already. Nah. What about depth? Nah, fuck it. Alright, well, let's just brute force a solution. This one, subtract that one. And then we want to saturate that, probably. And then use that in our opacity doodad. Bam. And this will give us nothing. Okay, okay. Other way. Dr. Jero, how's it going? Okay, this is almost correct. It's doing it everywhere but where I fucking want it. So maybe it's just that 1 minus. There it is. Bam. We've masked a stencil over a particular mesh. And that should work. Yeah, it's pretty consistent. So there we go, Jerry. We've done it. We have done it. And so these other ones here, they're also receiving decals, don't forget. Okay, wait, now we're getting the flickering. So I think this is due to there being a tiny... it's like Z-fighting. So I think we just need to add... Oh, you can see it a little bit here. We just need to add like a tiny little offset, which will cause it to sort of bleed over onto other things very slightly. Now there's probably a better way to get rid of the flickering and shit at the really steep angles, but I'd just give it like 5 centimeters of safety. Yeah. Like decal channels or something. Yeah, exactly, exactly. So, but you have to define it in the decal itself. In the decal material, sorry. Or you could even do... You could even, you could set this as a parameter, you know, so you could have this version of the decal go to stencil value 3, and this decal here go to stencil value 4 or something. Or you could be really smart if you wanted to, and you could define stencil ranges and be like, okay, this stencil appears between stencil value 4 and stencil value 135, and any mesh assigned to any stencil channel between those values would receive this decal. So there's plenty of ways you could fuck with it. Is there a decal color or parameter value on the decal itself? Oh, you mean like the... fuck, what is it? Decal color, which then automatically feeds into... Yeah, you could use that. For sure. There's some other decal functions. Decal derivative? Oh, right, DD. Yeah. Lifetime opacity. These are essentially just like... what do you call it? Custom data. Custom data values that are just kind of hard-coded into the material graph and whatnot. But yeah, you could use the decal color to drive the stencil mask thing. But yeah, plenty of ways to get the desired outcome. Yeah, so that's it. That's it, man. Alright, let me get comfy. Also, how's the Twitch stream health going? It looks like it hasn't been too fucky. It says I have some viewers. It's not constantly resetting. All good? Hell yeah. Glad to hear it. So yeah, basically I'll be making a video about the decal thing. Fuck, maybe I should even, now that I've just figured it out. I mean, like, it's pretty, I don't know. I'd probably want some more advanced shit, you know? But at the same time, is there really that much advanced stuff to do? The other thing you can do, by the way, Jerry, which you might like, is you can get the world normals from here. World normal. And you can get the decal... Well, it's not the decal normal. It's the... Oh, but these are like fucky as. Like, they're like fucking... X forward or some shit. It's like, bruh. I want to get this. Is it just X forward? Ah, fuck, I don't even know. Get this transform. Fucking shitlord space to... Logo space to world space. Does that give us the right color? Oh, that should probably be... Okay, that's facing up. And this one's facing down. Which is fine. It's facing down, negative... Would you guys... Okay, let's say you guys were looking at this decal, right? Would you say that this decal is facing down? Or it's facing up? Because, like, I think of it as it's facing up. When it's projecting onto the ground, you know? Am I crazy? I think for the sake of this demo, yeah, it's whatever. So yeah, anyway, we'd get this shit, we do that, get the world normal, dot product between this dude and that dude, and then saturate that, and then multiply our dude by our mask. And now we should only see it. Yeah, so we can kind of get rid of the bleeding by doing it this way. like over the sides and whatnot. Although now, because I'm doing this, maybe I should be subtracting it. Let's add negative some value from this guy instead of adding it to the other guy. And that should hopefully get rid of this fuckery. No? We'll just add positive value there. No, but now it's just not. How to get rid of this stupid custom depth line? You'd have to do like a threshold rather than a thingo, right? Where you do it here and then have some value. Right? Or am I just crazy? No, because that's going to do it everywhere. I don't know. There's some method to stop the bleeding and shit, but... yeah, the gist of this is that you can... You know, if you've got, like, a wall, you can stop it from projecting on the back face of the wall. Like, if I had, like, a big, thin wall, like this, and we have a decal... And that decal was not completely fucked. We can tell this guy to project onto this wall, but it won't project onto the back face. It'll just project, you know, in the direction that it's... And this can be as fucking big as we want it to be. So yeah, that's another decal masking technique. And this should respect like normal maps. So if this was like cliff something, I don't fucking know. If this was whatever. And then I like did this, it should... Oh god, I don't know. But yeah, it works, trust me. Just YOLO. Anyway, that's enough of that. Tis enough, tis enough. What's that? That's a ball. Okay, so I need to set up our thing for the stuff. Filming this Grid2D video. How do you place a decal on the ground, but pawns that have to accept decals as well when they get projected onto them? So that's if you rewind about 10 minutes, we were just doing that here, where you can use custom depth stencil to essentially only project it onto some meshes and not others. So this decal here, maybe this is like a blood splatter decal. We can say, okay, yeah, blood splatters go in channel 5. And then only things that are, you know, in number 5 will do the thing. You could also use this as an exclusion mask. Because, like, let's take the example of characters, right? Where, like, maybe you've got, like, these, like, kind of magic effects where you're doing like these big magic circles on the ground, but you don't want it to, like, you know, clip into the characters and stuff, but you want it to go on the landscape and the landscape grass and all of the environment props and all that kind of stuff. But you just don't want it to go on characters. You could say, okay, characters, draw to custom depth pass, channel 1, stencil mask compare, 1 minus that, put that into the multiply. And so this decal will now appear on everything that accepts decals, except things that are in custom stencil number 1. And that means that you don't have to, like... The less things that are drawing to the custom stencil or custom depth passes, the better. Because it's like, you know, it has to do an extra depth pass, which is a whole rendering chunk. So, you know, if you just want to exclude the decals from going onto something, then, yeah, you kind of want to do the opposite. So I want to exclude this from going on characters and other things that shouldn't accept, you know, magic circle decals or whatever. Or like ground VFX decals. So yeah, hopefully that gives you some ideas at least. And yeah, I will be making a video about this. I'll probably film it tonight. I've got plenty of time. But I do want to do the Grid 2D video first while I have a voice. Let me just call this decal masking methods. Alright, so we're going to start the Grid 2D video from scratch. Yeah, fuck it. Can I make all of their X scales bigger? I can. It's good enough. Cool. Alright, alright. Craft Rain, so the Grid 2D tutorial. No worries. I'm redoing it. I mean, I know the VOD is still there, but I'm gonna. I think I can be more concise, precise. Both. Concise, precise, precisely, concisely. I need to first change my screen res to be small baby monitor, and then go to this scene. Yeah, it's better for the videos, which I hate. Ugh. Yeah, I'm glad. I mean, yeah, like, all the info is there. It's just that I think I can do it faster and with less faffing. Less faffing about. Alright. Do I have water? Not really. Not really. Ugh. Do the stretches. Alright. Clear my nose. Just gotta... Ugh. Stretch my jaw. Stretch D's. Okay, maybe that should be bright. Cool. Let me also just put in a little spot, not spotlight, what's it called? Point light. Whoa, Lumen? Look at that bounce lighting. Whoa, is that Lumen? No, it's not. This is how we used to do bounce lighting back in my day. Back in my day. Alright. Zoop. Everything's set up. We're pretty good to go. Alright. Why do I look like a hobo? Hello and welcome back to another Prismatica Dev video. Today we're going to be talking about Grid 2D. Alright, start recording. Hello and welcome back to another Prismatica Dev Niagara Particles video. Today we're going to be talking about Grid 2D, the two-dimensional grid compute shader system within the Unreal Engine. So, let's jump straight in. What the frick is a Grid 2D? Now, if you're watching this video, presumably you already know what a particle system is. You know, at least in Unreal's sense. Just imagine, let me just get paint going. Oop. Let's imagine we have thousands and thousands of particles and we arrange them in a grid. Oh god, this is going to take ages. Okay, let me just copy paste it now. Is it really Why did Alright, we got there. So let's imagine we have a whole bunch of particles, and these are all existing on the GPU, and they're arranged in a grid. Now, you might look at this and you might think, wait, isn't this what a texture is? Isn't a texture just a grid of pixels? Like an array of pixel values, color values, whatever, and then it gets arranged in a grid, from left to right, top to bottom. And you would be absolutely correct. That is literally what we're dealing with when we're dealing with a Grid 2D system. It's essentially a particle system in the shape of a texture. So what can we actually do with this? Well, we can do things such as set the color of certain areas or, certain groups of our particle system. So we can say, okay, given this location, we're going to color you from 1 to 0 based on your distance from this point. And we can essentially draw a circle with like a soft fall off or something. Or we could sample a texture onto our grid system. But the one thing to keep in mind with a Grid 2D system is that our particles in this case never move around. They're in a fixed position, but we can access our neighboring particles, and do some funny stuff. So we could say, okay, for this pixel... And so as we go through our list of particles and we update them one by one, or in chunks of 64 by 64, because we're on the GPU and whatever, we can essentially ask them, hey, like, for this guy here, let's say this particle is white, titanium white, and the ones around it are black. We can say, for this pixel, let's get the, you know, the average up, down, left, right, and itself. Add them all together, so that would be, well, 1. And then divide it by the number of pixels, divided by 5, so that would be 0.2. And then we ask the same for, you know, all the other pixels when they have gone through. We ask them, hey, what's the average of your surrounding? This one would return 0.2, this would return 0.2, and essentially we'd end up with a blur. And we can just keep iterating on that blur over and over, and we can blur things out. So there's a ton of magic that we can do with Grid2D. As another example... Oh, where's my fucking plugin thingo? Here we go. So, if we look at... Hello? Why did... Huh? What? Why is this not... What? What happened here? What did I delete? I must have deleted something. No, there's no... I don't need the manager now. How? Why is this... Alright, you know what? Stop the Stop the recording for a sec. Why has this stopped working very suddenly? We have manager. Manager has... main sim grids, yeah. Okay, they don't have values, but the... render target... Huh. Let me just restart editor. Oh, you know what it is? I bet you it's the RVTs. I bet it's those RVTs nuts. Run time virtual texture volume. Yeah, it would be this. Let's go interaction height, water height, and water data. Why are they not? I mean, are we getting Pris.debug shapes 1? Okay, they're definitely there. So it's just that our RVTs are a bit fucky. Is it just because they all have stupid settings? No, that's fine. Is it the streaming pool size overflowing? No. Do any of these work? That's what I want to know. What did I change about the RVTs that would be fucking it up? Definitely drawing land interaction height, water data. Yeah, YCOCG, blah, blah, blah. Land interaction height. If I just make it, like, smaller, is it gonna be less fucked up? Bruh, where am I? Oh, maybe it's in here that it's gone fucky. Interaction bubbles, deform capsules. Grid location, world space, water data, water height. Did I just like unhook something maybe when I was faffing around? No. When I was doing the grid stuff. It's just not getting the heights and shit. If I just like set up pixel landscape height 0, which would be, oh yeah, above that. Okay, we're getting some stuff. Okay, what Z height is this at? That's at positive 70, right? Debugging these nuts. Yeah, so it's just the RVT isn't being read properly. Why would that be? What have you done, Niagara? Why you do this to me? In the manager, I don't have to set them explicitly, do I? They all just get set in the... Yeah, they're not parameters. They're in the actual thing. Ugh. Note. Oh, it's experiment. No, the note is sample RVT. Really good. Let me just set these to null. And then compile. And then set them back to landscape or interaction height. Land interaction height. Water data. And this is water height. Compile, save. Unless it's just like getting the wrong position. Maybe I fucked something up here. When I was dicking around with the Grid2D stuff. Is it because of this? I'm guessing it's just a bung node? No, it was just that. Why did I change? Right, I remember now. It's because when I was fucking around in the old Grid2D video, I was like, oh no, it's supposed to be the other way around. And so I switched it because I had that open to reference it. And then I thought I was switching it in the other one, but it was in this one. So yeah, no, that's all fine now. All right, crisis diverted. Crisis delayed. Okay, so what can we do with Grid2D? Well, for example, if you've seen my Prismatoscape videos, all of this stuff, all of the the grass trampling, all of the, you know, the wind simulation, all of the footprints. Oh, you can't really see them. All of these footprinty thingos. All of that fog interaction, all of the water ripples, all of the water foam, all of this stuff. Oh. Where's the frickin'... this one. All of these systems hinge around the Niagara Grid2D paradigm. So if we actually look under the hood at what this is, or what it is doing, then we can see that the output of... oh. Then if we actually look under the hood at what... oh, God, no. Oh, no, it's fine now. Okay. So if we look under the hood at what is going on here, you can see that we have this render target output, which is being read by our shaders as just, you know, a regular texture. And we're then telling our, you know, foliage shaders to do... basically just jiggle around and bend in the direction of the wind that we're creating using our Grid 2D simulation. Getting addicted to it. Okay. So, you might already be thinking, well, this sounds super, super complicated, and surely I'm not going to be able to, you know, use something like this and create something, you know, as fancy and complex and pointless as this. But in today's video, we are going to do just that, or at least the basis of it. So in this video, what we're going to be doing is we're going to have some balls, and those balls are going to draw circles, or like kind of soft circles, to a render target. And as those balls move, they're going to create trails, and then those trails are going to fade out or blur, or maybe we could even draw some velocities of the balls to the simulation. And, you know, let's say red is the color of this way, and maybe we could even have it blur out in that direction. You know, a very primitive fluid simulation of some sort. So that's what we're going to end up with by the end of this video. But it all starts... but the most difficult journeys start with the smallest of steps. So let's go back to our dude. Let me just find the fucking folder. Niagara videos, Grid2D video. Oh, I need to go to this one. So, in this scene, I have a very simple setup. I've got a little ball arena, for the balls to sit in. I have a mesh, a plane mesh, which is what we're going to be, you know, representing our texture on. I've got a little light just to light things up a tiny bit, and that's it. That's all I've got in this world. So we're starting from pretty much scratch. And considering we are starting from scratch, we need to make a bunch of assets. So let's go right-click. We're going to go to Texture. And we're going to go to a new render target. We're going to call this Grid 2D Tutorial. You can't even fucking see it. Hold on. You shitlord. Alright, so let's right-click in our content browser. We are going to go to Texture. We're going to go to Render Target. And we're going to call this one Grid 2D Tutorial RT. RT for Render Target. So if we click on this, you can see we have a blank render target. And if I get my details back over here, you can see we've got things like what's the dimensions of it, what's its clear color, you know, what's like its kind of default color, what's its format, all of that stuff. We're just going to leave that exactly how it is because we're going to be setting all of those variables in our Niagara system. So, secondly, we need a Niagara system. So we're going to go right-click, Niagara system. We're going to do a completely empty Niagara system. Or I think if you search up empty, yeah, completely empty, but it's got an emitter. So we're going to call this Grid2D tutorial system. Why not? And we're going to double-click on this. And we are greeted with a completely empty emitter in a standard system. All right. So this is where things are going to get funky. Firstly, we need to create some variables. Now, this step is a little bit confusing, so just follow very closely. We need to go a new user variable called texture render target. You know what? Let me just fucking double check this. This bit is really fucky. Let me just go to like Prismatiscape or even the... Where's the thing? Go upper folder. You little shitlord. It is texture render target. Okay. Yeah. Alright. Okay, so let's click on our emitter. We're going to go... this should be like that. Okay. Right, let's start again. So we're now in our completely empty Niagara system with a completely empty Niagara emitter. Let's go up to here, user exposed parameters. And we are going to click this and go texture render target. Let's just call it texture render target. It doesn't really matter. So this is going to be, if we go to our user parameters up here, we're going to set the default of this one to be our tutorial Grid2D render target. So that's just our default variable, or our default setting of this variable. And then in our emitter attributes, we need to make a Grid2D collection. We're just going to call this Grid2D collection for now. Or should we? You know what? Let's just call this our tutorial Grid2D collection. And we also need to make one that is a render target 2D. Now you might be thinking, didn't we already just like make one of these things? It's a little bit faffy, but we just need to drag this guy into emitter spawn. And then we're going to set this variable to be this variable that we created up there. So this is pretty much just like passing the variable along to something that can be used in the rest of the system. It's just a bit funky because like texture render target is the base class for texture render target, which includes 2D and volumetric render targets. But then you can kind of think of it like we're casting down to render target 2D from texture render target. Now in here you can see size 0, override, you know, the format and whatnot. We're just going to leave them all blank, because then what we will do is, click on emitter spawn. we're going to click library only off because a lot of these are like hidden. And we're going to go grid 2D set resolution like this. And the grid up here, so where it's got this little, I don't even know what this is. It's like a stack of coins. We're going to drag our grid 2D collection onto there. You could also just like find it in here, grid 2D collection tutorial. Okay, you know, what the fuck isn't it? Well, fuck it. Anyway, we're going to drag from here over to there, and you can see we can then set the number of cells, etc. And then we're also going to add an init RT, grid2D initialize render target. So our grid is this guy up here. The render target is this guy here. And this is pretty much going to set the render target's values to match that of our grid. Okay. Pardon me. There is also one other thing. I think we need to like chuck this in there to set the format. Yeah. Alright, so there is one last thing to do, and that is to just get our tutorial grid 2D collection. We're just going to yeet that. We're going to put it second in line. And then what we will do here is... Wait, are you even... No, yeah. We want to leave this grid 2D collection blank. And if you want, you can override the buffer format to be half float, which is 16-bit. A full float is 32-bit. And then 8-bit is the last one. Usually half float is fine. And this will like save you, you know, twice as much memory. It'll halve the memory cost. It used to be that there used to be a kind of bug where like you had to do this to essentially initialize the grid 2D into existence. I don't know if that's been fixed or not, but look, it's just a decent idea to just chuck this one in by dragging it up to here and then override buffer format to whatever format you want to use. So then grid 2D set resolution. This is whatever resolution we wanted our 2D grid to be. These can be parameterized, so you could be setting these from a blueprint. So we could have a user exposed variable of type integer 32, and this would be called, you know, grid resolution. And we can just chuck that into there and chuck that into there. And then we just need to make sure that we set, you know, a decent variable default. 128 by 128, that's fine. Let's go to 512 by 512. And then if we actually go and drag this into the world, just so it's actually, you know, computing in real time, and look at our Niagara Grid system, we should see these variables be updated. But for some reason, they are not. So why the fuck is this? I guess set number of cells? No, that's... I just want to die. I just want to fucking... You piece of shit. Emitter spawn. Do your thing. Yeah. Yeah. Do I have to do spawn state? Oh, sorry. Emitter state. But is that all right? And the last thing that we need to just double check is that in emitter update, we have the emitter state module running. This essentially just, manages the life cycle behavior so that when it's spawned, it will actually do all this stuff and update them. So we hit compile. Let's just set our grid resolution to, I don't know, 123. Some weird number. And then we can check our render target, and you can see that, yes, it is set to 123, and then if I change this back to 512, you can see that our render target has updated to be that resolution. Now, we also just want to check that our render target format is changing, so this is 16-bit, RGBA 16. If we go to our thing here, override buffer format, if we go to float, then this should update to say, son of a bitch. Shouldn't that do it there? Oh, wait, do I want to do that? No. Fucking donga. I guess that is the grid itself, and this one is the format. Yeah. Yeah, so this actually changes it. Why is making videos so hard? Alright, and if we just want to double check... Oh, bleh. And if we want to change the format of our render target, which is different to the format of the Grid 2D. So the Grid 2D is kind of like all the working data, and then the render target is the final output. So maybe we'd want to be working in 16-bit, but then our render target, we might just want to be, RGBA 8, just to save on some juice, for example. So we don't want to set the size in here, mainly because the size parameter here cannot be parameterized. It can't be changed by a variable. So that's why we set it further on down here, where we can actually put in, a user variable. But the format, we want to change in this guy here. So for the sake of simplicity, we're just going to set this to be 16-bit render target by overriding the format. Our Grid 2D is going to be in half float, which is 16-bit. And then our resolution is whatever our variable here is, 256. And then initialize the render target, which will transfer the, and then initialize render target, which will transfer the grid's resolution to the render target. So we hit compile, we look at our render target, it's got the correct resolution, it's got the correct format, and so that is step 1 completed. We've completed step 1, which is actually hooking this up to a render target. Now, one other thing that we will need to do before going further is we need to actually set this to be a GPU compute sim, which is, yeah. So this needs to be a GPU compute sim for maximal, God, I don't know, for maximal performance. I don't even think they let you use Grid 2D functions without it being on the GPU. And then we're going to get an error saying, oh, you need fixed bounds. We can't compute dynamic bounds on a GPU particle system. So just set it to fixed. These don't actually mean anything because a Grid 2D doesn't exist in the world. So it's just always going to be running, regardless of whether we're looking at it or not. And with that, we are ready to move on to the next step. And then we're going to fade to black. And then we're going to fade back in. So, let's talk about how to get data. So, in our next step, we need to do, again, a few more little setup stages just to make sure everything's working because these Grid2D systems can be quite hard to debug, especially, you know, as they are quite complex and obtuse. So what we're going to want to do is we're going to create a new stage, and it's going to be a generic simulation stage. Now up here, the execute... Oop. Now, if we click on this, we can change the name. Let's call this draw to render target. And the iteration source is going to be data interface. And then we get these data interface parameters down here. And we're going to click tutorial Grid2D collection. So this is saying at this stage here, we are going to iterate over every cell of our Niagara Grid 2D. So in a regular particle system, it's just set to particles. So iterate over all active particles, as it says on the tooltip there. Data interface is iterate over all elements in the data interface. So this is for more like custom thingos. So number of iterations, 1. Tutorial Grid2D collection, we're going to iterate over every doodad. The execute behavior, this is, do you want it to run all the time? Do you want it to run all the time after the first frame that it's been created? Or do you only want it to run for the first, you know, update cycle when it's created? So if you've got anything like setting initial parameters, you want them to run on simulation reset, but then everything else you want to run not on simulation reset or on always. So, the basis of Niagara Grid 2D is custom modules. Now, you've probably watched my, you know, Niagara custom module video. It should have been out by now, but it's not. So we're going to just create a scratch pad. You can make more modular things, but for a lot of these Niagara Grid 2D simulations, you'll just be using a bunch of scratch pads to do a bunch of random stuff, just because it's kind of written. It's not like 100% of the way there yet. But we're just going to do one called draw to render target. We're going to create an input, which is the render target 2D. Then we are going to get our grid 2D collection. And technically we don't need this map set here, but we're just going to say set render target value. And we're going to join that up. And we're going to get our grid 2D collection, which is the thing that we're, you know, executing, you know, for each pixel. We're going to go execution index to unit, or we can go execution index to grid index. So this is pretty much saying, as we iterate over each pixel or particle, what is its index? So this one is 0, 0, this one is 0, 1, this one's 0, 2, blah, blah, blah. This one is 1, 0, this one's 2, 0, and obviously all of the ones in between. So this is just giving us the coordinate of the current pixel. And so that's what this one here is doing, returning the actual coordinate of it. This one here, the unit, is returning almost like the UV space. So this one is 0 up here and 1 over here. And so this pixel here would return 0, 0.5 or something close to 0.5. Whereas its coordinates or its index would be, if this was like 128 pixels long, then the one in the middle would be 64. So we can see how these both kind of function by... that's a dumb example. So what we can do is we can get the current index and set a value on our render target based on the current thing. So this is essentially saying as we scan over all of our grid 2D points, we're going to get the matching pixel on our render target, and we're going to essentially transfer the value from this guy and just smack it into there. And so what color do we want to make our render target? Well, let's go pink for now. Apply the scratch pad, and so we apply the scratch pad, and then we just need to make sure that we're passing in our variables. So render target 2D, this is going to be our render target 2D, and the grid collection is the tutorial grid 2D collection. So we're now passing in the correct variables into this function and then running this computation. So if we actually look at our render target, you can see that we're saying for each pixel, draw this color. We can set that to blue, apply that, and bam, it's doing that. And it's doing that every frame. What we could do to see what this unit returns is just plug unit into here. It'll do a little converter, so RG and B. And you can see that we'll just end up with a regular old UV space. We've got 0 up here, we've got red 1 on this side, we've got green 1 down this side, and combined, we got the black, we got the yellow, black and yellow, black and yellow, black and yellow, black and yellow. That was dumb as fuck. Alright, I need to pee real quick. So, BRB. BRP. PRB. PBR. Sorry, I let the cats inside. And I opened the door to let Lady Cat in. And then I heard Girl Cat meowing, and then I looked and she was on the roof. And she always carries on when she gets on the roof. Bloody cats. She like meows and meows and meows. Like she can obviously get up and down perfectly fine. But whenever she's up high, she just like meows at me. I don't know if she wants me to climb up there or something. I don't know. I don't know. Alright, where were we? We just got our thing drawing. Cool. Pardon me. So what did I want to do next? Okay, well, we need to actually draw some values. Okay, so we've overcome another obstacle, and that is drawing some values to our render target. Whatever value we choose, you know, whether that's just a solid color or a UV space, or what we're going to be using it for is to draw trails of balls. So, how the frick do we actually do that? Well, the first thing to do would be to create a new material. This is going to be called our Grid2D tutorial material. We're going to schwack that onto there. And in this material, let's just press T and click to get a texture. We're going to get our Grid2D tutorial render target. And we're going to yeet it straight into here. Now, we're kind of skipping over some steps. For example, you might want to project this render target on like an infinitely large plane or landscape, but only in a certain position, or only in a certain position around the player or the camera, kind of how my Prismatiscape plugin does it. We're just going to skip over that for now and just work with some hard-coded presumptions. For example, our plane is at location 0, 0. Our plane is also 512 centimeters wide and high. And we're going to set our Grid2D. Oh. Here it is. And we're going to set our Grid2D to be 512 pixels wide. And so, essentially, we can just cut out a lot of the faffing and get our positions that way. We will actually do the calculations, but I just cannot be bothered sending them in to the system and updating them in real time and whatever. We'll do that later. Let's just get something exciting happening first. So, how do we want to draw these trails? How are we possibly going to draw trails onto this thing? Like, where's the draw trails function? Well, there isn't one. Too bad. We're going to have to make it from scratch. So we're going to do another simulation stage, generic simulation stage. We're going to call this one Draw the Balls. We're going to yeet this one up to, well, as high as it can go, which is just above this one. Again, we have to go iteration source, data interface, Grid2D collection. And let's just draw this always. And what we want to do is, again, make a new scratch pad. You can make this, you know, later on as an actual module if you want. But let's call Draw the Balls. And we're going to be using an array of values But for now, we're just going to hard code some, and I'll show you the basic math of what we're doing. So variables that we need are the 2D, vector 2D, simulation, location. Let's call it simulation location center, because there are several ways of, doing this where, like, you would anchor your location at, like, the top left corner. And also keep in mind that the way I'm looking at this is that X is... Pardon me. The way that I have this oriented, and I'm doing this very much on purpose, is that X positive is going to the right, and Y positive is going downwards, or towards us, and Y negative is away from us. The reason I'm doing this is because that is just the coordinate space that, a UV, texture UV would be using. It starts 0 in the top left corner, and it goes 1 this way, and it goes 1 that way. So just keep that in mind. So simulation location center. We then need our resolution, which is an integer value. Let's call this sim resolution. Doesn't really matter. These are just inputs to the function. So then we need another 2D vector. This is simulation size world space. This could be a float, but you might have it like squished. It might be rectangular instead of square. You could also use resolution as a width and a height integer if you were doing that kind of thing. We're just presuming that we're using a square for now. We also need the grid 2D collection. That's probably the most obvious one. And I think now we have everything needed to do some stuff. So, refers to notes. I need to refer to my notes. Because I'm so dumb. Let me go to... Can I go upper folder here? No. Plugins, Prismatis. Okay. Prismatis. Okay, there it is. Alright, let's make sure we don't here we go. We don't fuck around with this too much. Let me just get this working first. Let me just stop the recording. I'll get this working firstly. So this is actually supposed to be a 2D fella. That is the... So that's size. Oh, you fuck. No, get out of there, you dog. There we go. So size... No, what do you... Size divided by resolution. Here. And this is the resolution divided by 2. And then that's the grid. So that will get the center point. Multiply it by the cell size in world space. And then we don't actually subtract it there. We do it this way, I'm pretty sure. Which is the location center. Although I can't, maybe it was we added it or something. Let me just check this. Yeah. This should be... actually, no, you know what? That needs to be a 4 vector. Vector 4. Yeah. Stack context. Smack him in there. Cool. Oh, you son of a bitch. Can I just, like, fucking make a vector 4? Oh my god. Make 4 vector. You go into there. You break Oh my god. Break vector 2. I fucking hate these, like, numeric nodes, you know? Don't need to convert an integer to flow before using it in a divide. It'll just do that. It'll do that in here. The Niagara numeric, everything's just a wild card. And yeah, it handles all of that inside the little doodads. Let me just... Alright, we got ya. And then draw to RT. We're gonna get a 4 vector, ya. Smack that into there. And then draw the balls. We need 2 here. Set that as ya. And we're getting nothing. Okay, so is it because... all the other things aren't set. Location center is 0, 0. Resolution is 512. Size world space is 512 by 512. The grid 2D is the grid 2D. Bam. Alright, now compile. So now that is at world center. Everything's in the correct orientation. And then if I said the location center is 50 units to the right, then it does go to the right, so that's good. Okay, so this is the correct way of doing it. How can I format this so it isn't super stupid? Alright, let me get rid of this. Remove pin. Bam. Last time I drew my balls, the police came looking for me. Oh, yikers. Alright. Oh, you little piece of shit. Well, yeah, okay, but fuck off. Get the fuck out of here. Okay. Let me also just go to the oh fuck, what? Oh no, I got rid of the user parameters. What's the other one? Window parameters. There it is. This one, delete. This one, delete and delete. Delete this. All right. Oop. Recording. All right, it is time to do math. So, let's get our grid execution index to grid index. I could do this a less fucky way. By doing resolution. Fuck it, this is fine. Actually, no, you know what? Location center divided by resolution, simulation size, world space. Because I could just get unit. XE to unit. So then 0 to 1 would be this multiplied by this. And then like that? Oh, now I have to do this again. Balls. That's a fucking twofer. Whatever. Stack context. Balls. Draw to render target. Just give me balls real quick. Previous 2D. Value. Balls. Smack that into there. Does that give us the correct... Well, no, we'd have to do the size. Yeah, you know what? Fuck it. I'll just do it the way that I know how to do it. Let's get rid of balls. Alright, now this is going to get angry because it's like, oh. Well, actually, no, that should be fine. Okay. Okay, so now we have to do math. We essentially want to say, given a location and a radius, draw us a ball. Draw me a ball. Give me the balls. So how do we do that? Well, we want to go get the Grid2D execution index to grid index. We're going to get our resolution divided by 2. Then we're going to subtract that from each of the X and the Y doodads. So the reason we're getting the resolution divided by 2 and subtracting it is so that we're offsetting it to the center. So, you know, if you take half of the resolution and you subtract it, you end up shifting you end up putting 0, 0 up here to 0, 0 being here, because this used to be 0.5, comma 0.5. We've subtracted, you know, half, and now 0, 0 is over here. Now 0, 0 is in the middle, negative 0.5 is over here, positive 0.5 over here, whatever. Checks math. It checks out. Cool. Oh, fuck. Alright, next thing we need to do is figure out how much world space each pixel of our grid is taking up. So we're going to get the simulation size world space, and we're going to divide that by the number of cells that we have. So that's pretty much saying to us cell size in world space. Then we're going to turn these into a make vector 2. Vector 2D, just smack them into there. It'll do all the conversion for us from integer to float. Then we are going to multiply our cells in world space by these guys, the remapped, you know, cells position. Then we just need to get our simulation location center, and we subtract it from the result here. Double check that. Yeah. So we're left with this big spaghetti monster. It looks really dumb. I'm just going to grab this and go move pin down below that one. So it is all the way down there. Grid2D collection, move pin up. Oh, move pin up again. There we go. And that looks sort of decent, I guess. I can probably get rid of this comment. No, you know what? I'll keep the comment there. And then we're just going to tidy up a tiny bit. Let's make it not look like shit. There we go. Handy. So, what this is... I can probably get rid of that. So what this is giving us is where is the location in world space on our grid. So what we will do just to test is... Let's make a thing. Let's go make a vector 4. We're going to call this... Let's call this final color. And I'm going to spell it like a real person with a U. And let's just go make vector 4. And we will... this doesn't know that it's a... Let's do break. We can't... Okay, let's go break vector 2. No, we can't find it. Okay, let's go make vector 2. So let's go make 2D. Then we're going to drag off of this pin, because it knows that it's a vector 2D. And we're going to break it. And then we're going to sever it. And then we're going to put that into there. And then we're going to put the X into there. And the Y into there. It's just a bit... It can get super finicky using these default, like, break and make nodes, because this is still a... This thinks it's a wild card, even though, you know, we've clearly put in a 2D. You know what, just... You'll learn to live with it. You'll learn all the tricks. So anyway, we're setting final color. Making sure that our namespace is in stack context rather than local or particle or whatever. Stack context is pretty much just like the safest variable type or variable namespace to use, because it figures it out based on the context of the stack. So in a Niagara Grid 2D, when we set a variable, it's going to set it back on the Grid 2D. So this is saying for the current pixel that we're iterating upon, you know, the one that is at this location, we're going to set its value for this variable type to final color to be bleh. So when we actually set a variable out in the open in a Grid 2D system, we're pretty much saying for the pixel that we're working on, you know, in our big pixel list of pixels, we have essentially like variable layers. So we can have like as many different variables as we want. So I can have one that's like a 2D vector. Ah, fuck you. So I can have one that's a vector 2D called like world position this pixel, you know, and I can set that to stack context. And I can even just save this world position for later and use it elsewhere. And that's kind of creating almost like another dimension to our grid. So you can have as many variables as you want, and they all just get stacked on top of each other. You know, for this pixel, we can have the final color here, and the world position here, and some working data here. You know, for a fluid simulation, you would have the pressure at this pixel, and the wind velocity at this pixel, and, you know, the boundary conditions at this pixel, all just stacked on top of each other in the same place. But anyway, we're getting off topic. So we're getting our world position, smacking it into here as a variable called final color. We're then going to go to our draw to render target fella. And there are two ways we can get variables into our render target. One of them is by using the get previous, you know, vector 4 value. And this was called final color. And we'd get it at this index and smack that into there. Or if you were writing a kind of generic function to write to the render target, you could just get a vector 4 value here called, you know, what to draw to the thing. And you could plug that straight in here. And you would just set it as, you know, an input variable. So in draw to RT, we have this variable, what to draw to the thing. We get that. We look for final color. And our final color is now going into this thing. If we duplicated this fella, you know, duplicate it, we can set a different variable. We could also set a different render target if we wanted. And we could do it that way. So let's just, again, we won't get too complicated. We're just going to get our final color. You can choose whichever way you wanted to access that variable. And then in our draw the balls function, we just need to make sure that all of these are set correctly. So our resolution was, well, we can use our resolution variable. Our size in world space was 512 by 512. Our simulation location center was at 0, 0. And we hit this. And you can see we now have the world space on our render target. So if we zoom in really... Oh, it's very bright. Nice. If we zoom in really close here, you can see there is a gradient going from red 0 to red 1. That's 1 centimeter. And so... and so if we go any further past this gradient, it's saying, well, this is red 0 to 1, and then here it's red 1 to 2, and then red 2 to 3, you know, all the way to over here, it's like red 256, whatever our half of our resolution is, whatever. Okay, so we can now... So now that we're getting the world space correctly, and we've proven that, let's just double check that we're doing it correctly by setting the location center to be 150 units to the right in world space. And now you can see that, yes, it has moved 150 units, and this is now our new center location. Although, actually, now that I think about it using my brain, this is actually incorrect, because this would be... because this would be, if we set this guy to 150 units to the right, we'd actually want that point to be in the original world space. So, again, this is what debugging's all about. I think we actually just want to switch this around. No, we want to add the center location to our kind of local space, rather than subtracting it. There we go. Okay, so now we've moved this over 150 units, but 0, 0 is in 0, 0. Now we can also just test if we moved 50 units in Y, and we reflected that in here, 50 units, then yes, 0, 0 is in its normal place. So I apologize for the confusion, but again, debugging is part of the process. I'm not gonna like put effort in and like, you know, do all this beforehand. That would be so cringe. Okay, so we have our world space. It's all working. We've debugged it. What? How do we get the balls? Where are the balls? You promised balls. Well, let's go into our draw the balls function. Yeet that out of the way. And I will show you how to draw balls. So, let's get a location. Our location is probably going to be a 2D vector. Oh, no, you know what? It'll be a 3D. Well, actually, no. You know what? We're probably going to want to pass in a 4 vector, because it's kind of the most efficient way to pass data into a Niagara system. So let's actually use a 4 vector. And what we will do, this is how I do it in Prismatiscape. We're going to have our ball location in XYZ and the radius in the W. And then we're going to have the velocity in XYZ here and a strength value in the W. Then we're going to use a convert. We're going to chuck this in there. These are really handy little converter nodes. So we're going to be converting this vector 4 into a 2D vector and a float and another float and XY XY goes into this one, the Z goes into this one, and the W goes into that one. And you can rename these. Let's rename this to height. Let's rename this to radius. And let's rename this to location XY. And then in this one, we're going to do another convert. Convert our 4 vector into a 3 vector, also just known as a vector, and a float. And this is called our strength, and this is called our velocity. So these are just completely arbitrary values, but we're going to use them to do some funny stuff. So, location XY of the balls. Let's get this and subtract our world space XY. And then we are going to use the... can you just do distance? I guess you could do... Okay, you know what? We can get the distance node. Oh, that's position distance. Okay, no, you know what? Fuck it. So, what we want to do is subtract our ball's location, the center of our ball, from every pixel's world location, and then get the length from it to there. So, if we look at... Son of a bitch. Let me just fuck this guy into there. Ah, you piece of shit. You know, it'd be way easier if I didn't fuck that up. Okay, let's just get... No, you piece of shit. Just to 4 vector? Fuck me. Make 4. Break 2D. No, break 2D. Oh my god, you're garbage. Break. Fucking get in there. X, Y. Give me the thing. Plug it in, baby. Alright. Oh my god, where is it? Why am I so... it's fucking this. Fuck you. Or is it? Am I just dumb? What have I cocked up? These fucking values got reset. Yeah, kill me. Alright. Stressed. So, if we look at our world position, and let's just say that we have a ball at 0, 0. So we're getting our ball's position, 0, 0, and for each pixel on our render target, we're going to subtract that value. So, subtract nothing in this case. So if we move over... Well, if we look at the very... Oh, fuck you. If we look at the very, very center, at the 0, 0 pixel, the distance from 0, 0 to 0, 0 is 0. So it's going to be a black pixel at the center. However, if we move 50 units over in the red direction, that is 50 units from 0, 0. So it has a length of 50. And over here, there's a length of 100. And, you know, if we go down, length of 50, length of 100. We go diagonally, length of 50, length of 100. So essentially, we're just getting the distance from the center of the ball. However, if... Oh, you son of a bitch. That's not the right thing. No, where... So that's why we're getting the length. However, if we then divide the length by the radius, and then let's just chuck that into the final color, and set our radius, well, our radius is set to 10 at the moment, you can... There we go. Oh. Then you can see that our fall-off is bigger. So that's because we're dividing it by 10, and so where the length used to be 10, it is now 1. And where the distance used to be 5, well, that's now 0.5. And, you know, if we put the radius to 100, then now where the distance used to be 100, that is now 1. And, you know, 50 is now 0.5. And 25 centimeters across is now 0.25. So this is sort of the backbone of our balls. This is where the bones are in our balls. However, you can see that we don't want the circle to be black. We want the circle to be white. So we're just going to get this. We're going to 1 minus. And we're going to saturate. And then put that in the final color. So if we look now, we have a ball at 0, 0 with a radius of 100. However, if we change our ball's position to be 50 and, you know, negative 25 in Y and apply that, then you can see that the ball has moved 50 units across and 25 units up. So when we have our actual balls drawing their trails and doing all the fancy stuff, we're going to be updating those values in real time, and it's going to be moving along with the ball. The other thing that we're going to be doing is drawing the velocity of the ball, which means that this thing that we've created right here is actually our ball's mask. And what we want to do is we want to mask the velocity value. Well, the velocity... Oh, fuck you. What we want to do is we want to mask the velocity value, also multiplied by the strength value. Doesn't actually... you know what, we can do it separately. Yeah. What we want to do is we want to mask the velocity multiplied by the strength and use that as our input. So if our ball was moving 50 units in the Y direction and it was bouncing upwards in the Z direction and moving, you know, 5 units per second in the X direction, then if I had set these damn converters up properly, my apologies, then we can see... then we can see if I... Why the fuck does that think it's a float? It's clearly a vector. Have you figured it out? Oh my god, you piece of shit. Oh, you... Okay, we're getting an error because of arithmetic conversion, blah, 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 because we've got a 3 vector here, but it doesn't know how to convert a 3 vector to a 4 vector. So we're just going to do a convert, and we're going to convert this guy, which is clearly a vector. We're going to convert that to a vector 4 by just putting X, Y, Z, and then into the W. We're just going to do a float, and that could just be 1. I really don't care. Just, oh my god, can you just, like, fucking... just fuck off, basically. Okay. Oh, God, they're so finicky. Okay, so now we can see we have a ball. The ball is, well, it's very white. But that's just because these are very high velocity values. Let's just put it down to, like, 1. Oh, let's just put it down to 1 and 0.5 and, you know, 0.1 or something. Just so they're all within the 0 to 1 color range. And now we can see that we have a green ball, which is representing that we have a ball at this location moving in this direction. And that'll be important later on. Alright, let me stop that recording, take a little sip. Alright, start a new clip. Okily dokily. So, we've now got our method of drawing balls. Now we just need to pass in all the information for some actual balls. And have some actual balls doing ball stuff. So let's just label this as ball, location, and radius. And this one's going to be called ball, velocity, and strength. And this is our ball mask, and this is our mask velocity by ball mask. Mask ball velocity by ball mask. Fetch me my ball mask. Okay, so one extremely cool thing that we can do in Niagara Grid 2D, or just Niagara in general versus materials, is we can use arrays of values and iterate over arrays of values. It's mind-blowing. Imagine being able to use an array of variables in a material. That would just be... So, what we will do is... First, we need to have a way to get these arrays into our... into our system. So we're going to go user exposed. We're going to do an array of vector 4s. Vector 4 array. And we're going to call this ball, location, and... radius, and then we're going to make a new one, vector 4 array, called ball, velocity, and strength. It is a compute shader, exactly. So we now have these two array object variables. Let's just go into draw the balls, and let's get our arrays in to this function. So vector 4 array, ball, location, and radius, and another one, array 4, ball, velocity, and strength. And then what we're going to do in order to loop over each ball in our array is we are first going to get the length of one of our arrays, because we're always going to be sending in the same number of values. I like to call this using parallel arrays, where you have multiple separate array variables, but they have corresponding values that all match up, but they're not actually linked together. Anyway, that's just what I call them. I don't know what other people call them. But then we're going to get this length, and we're going to use a very cool function called map4, parameter map4. And I guess we'll make a little reroute, smack that guy into there. And we're going to use that instead of map set. Well, actually, no, we're going to use map set, but we're just going to do it further along down here. So now we're just going to smack this guy into there. Now, the iteration count, you guessed it, is going to be the length of one of our arrays. I'm just going to chuck him up there. So this is going to iterate this many times and then move on to this guy. So what the fuck is this? Okay, you know what? Marked as experimental. Well, experiment these nuts. Unreal. Because I've been using this node since I was born. Born again. As an Unreal. An Unrealist. Forever I mean, Unreal Engine is forever experimental. Yo, Manoa! Welcome, welcome. Welcome, Raiders. How was the stream? I'll wait for you to say something so that I know that you're in here before I say stuff. So, we're going to iterate this many times, and we're going to get the current parameter map for current index. So this is which iteration are we on. And then we're going to get from our array and get from our array the current iteration indexes dude. So we might have 4 balls. I wish I had 4 balls. And for the first iteration, we're going to calculate ball number 0. Our 0th ball. So we're going to get ball location and radius 0 and velocity and strength 0. And we are going to smack that boy into here. And we're going to get the velocities and stuff, and we're going to chuck them into there. So we're replacing our hard-coded variables, which we might just keep floating around, just in case we need to debug some stuff. And we've now put in our array of variable length of our real-time updated ball locations. And so what do we want to do with these real-time balls? Well, we want to... Oh, piss off. Yeah, I know. Completely empty. Well, yeah, of course it's completely empty. Piece of shit. And so what do we want to do with our balls? Well, we want to... We don't want to overwrite... You know, so, for example, if we look here, we draw ball number 1 by calculating how far away is each pixel. These ones are all black, these ones are all white, and then we multiply them by the velocity. However, when we draw ball number 2, which might be over here, we'd then be recalculating. Oh, these would all be 0, 0, 0, 0. These would all be 0 as well. So we'd end up just erasing all of that shit. So what we need to do is have a new variable. This is called our... We'll do it as... We'll do it as a vector for... This is called temporary balls. And we're going to... Oh, can that not do a conversion, you piece of shit? Fuck. And we're going to grab this converter. It's really annoying, but whatever. I wish the velocity was just... You know what? Fuck this guy. Okay. We're just going to grab our velocity. We're going to do a convert. We're just going to convert our vector 3 into a vector 4. Just for reasons. You might want to use the alpha value for something, potentially. We're just going to do this for now. So we have temporary balls, but we want to get our temporary balls value, vector 4. Temporary balls. We want to get the local variable. And for each ball, we want to add them together. So we want to get... This will start at 0 for every pixel. We then calculate ball number 1. And we add it to all of the 0 values. And then set temporary balls. This will then do our next iteration, where we have temporary balls with ball number 1 drawn. And we then add ball number 2 over the top of it. And so we do that. Then what we will do is we will get, over here, we will get temporary balls at the very end after our iteration. And we will set that as final color. And we can probably just yeet that bad boy. Okay. Played some Genshin Impact? Hell yeah. I used to play Genshin a lot. Genshin was like my, my I don't know what to do with my life game. Where I was just bored and I was like, I'm just like so lazy, I'll just play Genshin. I'll just do my dailies. Just, you know, do a bit of do my daily bosses and blah blah. So yeah. So I'm quite familiar with Genshin Impact. It looks great. Genshin is a very good-looking game for considering how much how performant it is. I am doing VFX stuff. Yeah, I'm doing some Grid2D shenanigans, which for plugins, which I use a lot. I'm filming a tutorial at the moment, but I use Grid2D compute shaders for like all of this, you know, wind system bullshit, and the grass trample interaction, and the bush jiggle, and water interaction stuff. You know, all that AAA shit. So I'm just filming a tutorial on the basics of how to get this kind of thing started. It literally is jiggle physics. I mean, speaking of Genshin Impact, you know, we've got jiggle physics on the bushes. Not just on Mona's big fat ass. What? What? Excuse me? What? Who's Mona? What are you guys talking about? So yeah, we're working on compute shaders in a grid format. And then I also started on a... Sorry, Amethyst. Another endeavor, which is even sillier, which is like Grid2D, but in 3D. And we're using that to do like a weather system, which is a bit insane. So here you can see we're doing like a three-dimensional fluid sim that's going to represent the wind and the clouds and the temperature of the entire world, and then we just do some GPU callbacks on like a round-robin update to feed that back into the CPU. So the bitrate really likes the yeah, true. The bitrate probably loves the colors. Oh god, Jesus. Yeah, sorry for the blurry bitrate. So yeah, that's what I've been doing lately, but now I'm just trying to pass on my knowledge, you know. Company pulled out lots of math, I bet. Yeah, like a fair chunk. Well, this one here is relatively I won't say simple, but it's just... There's kind of like 3 steps to fluid simulation that are all pretty... I mean, the math itself, you know, someone figured out a century ago. Mr. Navier and Mr. Stokes, Navier Stokes, about like incompressible fluids and blah, 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 blah. But then in order to actually implement it in, you know, in a grid simulation, all you really need to do is just have colors. Oh, sorry, I'll wait for the ad to finish. You know what, I'll get some, I'll get a snack while ads play. There we go. BRB. I'm back. Perfect timing, Brunel. Perfect timing. Oh, I made a coffee. Delicious. Where were we? We were wrangling balls or something. I can't remember. Oh, no. I was explaining fluid simulation. Oh, wrong scene. Fluid simulation. So, the gist of it, of a fluid sim, is like, in a grid, if this particle, let's say like this clump, I don't know. Yeah. Basically, this guy here, if it's red, aka moving this way, so its velocity is positive red, then essentially what we do is whatever its velocity is, we actually backtrack from that, and we take this guy and move him there. Or if it's like slightly diagonal, like this, we move back. We probably end up like in between these guys to some degree. And we interpolate between them, and we move that value into here. Well, we actually get the average up, down, left, right of a pixel, and use that to backtrack, to then sample, to then set this as that thing. It sounds a little bit backwards, but it just works. It's because technically a fluid simulation, you're calculating the future in a weird way. But that's kind of how you move stuff around in a fluid sim. Then you just calculate, based on, this is a 3D one, so it's, the current index. Yeah, exactly. You're pulling it like a cloth. That is probably I'm going to use that analogy. That's actually a really good way of explaining it. So yeah, here you can just see I'm sampling wind velocity, up, down, left, right, back, front, because this is 3D. In a 2D one, you'd just have 4 samples. You can see here it's just the original XYZ, but plus the X, or minus the X, or plus the Y, minus Y, or Z, back and front. And then this just calculates how much... So, like, if we had these 4 cells... Well, actually, no. Let's just say this is our cell, right? That we're working on. And we have fluid pointing this way, and this one's pointing this way, and this one's pointing this way, and this one's pointing that way. If this guy was just to, inherit their velocities, then they'd all cancel out, and it would just go to 0. And it's like, well, that doesn't make sense, because that means that a bunch of fluid just, disappeared. So what we do is we calculate the divergence, which is this. How much is being lost. So even if these ones weren't even going in there, if they were going sideways, we'd still have some, convergence here. And so then we calculate that divergence, and we then pretty much, we kind of blur it out a little bit. It's, linear function solver, fucking whoop-de-doo, whatever. That's the pressure iteration, which I'm in the middle of adding boundary conditions to, so that's a bit messy, but usually it just looks like up, down, left, right, back, front, add them all together, subtract them from the divergence and the size of the cells and shit, whatever. Divide it by 6, or however many neighboring cells there were. And then we just take a gradient from that. So if you think of the pressure, the resulting pressure needed to push things away from diverging or converging, it looks like a height map. And you can do a height map to normals, where you've got a height map, And you can then get a normal map from that by doing like an offset left-right. To kind of like, you know, you end up with a normal map. I mean, whatever. And then you just apply that normal map to the velocity. And that counteracts that, you know, disappearing of fluid and stuff. And that's literally all there is to it. That's all a fluid sim is. And with just those 3 steps, you end up with... Okay, well, not this. You end up with... Well, yeah, something like this. Well, actually, no. Okay, to be fair, that has vorticity confinement, which is like an extra step to add more detail back in for all these like little curly whirlies. All the little curly dudes. Without vorticity confinement, you just have this kind of thing. Where like, yeah, it's still fluid simming. And it's still incompressible, and it's still doing stuff. For example, if I just get the Schwinger and the Kamehameha going, you can see that, yes, these 2 beams of air hit each other, and then they expand outwards. Like this. They hit each other, and then expand dong. But if we put vorticity confinement back in there, then we end up with a bunch of extra curling. Technically, you can... The reason vorticity confinement is good, or is handy, is that usually if you were doing a semi-Lagrangian advection method, you'd get the... So you know how I said, like, we get this guy, we get its neighbors, and we say, oh yeah, we're going to sample backwards and pull this guy into you. That's a fully linear version of it, which is what I'm using, because it's obviously the cheapest. Another way you can do it is you can say, you know, I'm gonna do 8 sub-steps, so then I'm gonna get 1/8 of that final velocity, and do that, and then I'm, you know, iterate over everything, calculate the velocities, then I'm gonna do another 1/8 of that step, and, you know, maybe this would have curled like this slightly. So it becomes way more accurate, and you actually get, like, curling and whatnot. But it's obviously a lot more expensive. So with vorticity confinement, you simply just do a linear fella. You know, like from here to maybe it's slightly incorrect. Or... Oh, I mean, it would probably end up at the same-ish location. Or maybe not, but whatever. And then you just calculate the spin of each particle by getting like, okay, if this one's going that way, then this one would be rotating this way. And if this one was going that way, it would be rotating even more this way. But if these were both going this way, then it wouldn't be rotating at all, because they'd cancel each other out. Or if this one was just not moving at all, and this one's going that way, then this would rotate this way. So, yeah. You just calculate the curl, and then apply that in another step to all the surrounding ones. And that way you get all of the curly shit back in. Use your fluids as a more performing version to UE's fluid Niagara system? Yeah, well, I mean... It's, Oh, sorry. Oh, let it go. Silly girl. Oh. Yeah, kind of. I mean, I'm using mostly the same logic as their ones. I'm just skipping a bunch of steps that aren't 100% necessary, and also doing it in a way smaller simulation size. And I also think some of the cost of the Unreal Engine Fluid Sim examples is actually like the rendering cost of like, they do like a ray marching solution, volumetric ray marching or whatever. What I do in here to like debug is I literally just have a plane like of like, you know, 20 transparent planes stacked on each other and then just look at it from above. Although you can just do this and set it to masked and used masked dithering. Like dithered masks to do volumetric effects as well. Which works perfectly fine, but yeah. Anyway, where was I? I was doing a tutorial about Grid2D. Right, we're in Grid2D land. Alright, let's go back to... No, not plugins. It's in content, dump. Niagara videos, Grid2D videos. This guy. Is that Fluid Sim a Niagara system? Yes. Yeah, it is. It's a Niagara Grid3D. The same as my Prismatiscape plugin is all a Grid 2D system. Or, I guess it is technically, yeah, one system. So all of this stuff is a Grid 2D fluid system. To do all the jiggle and the foliage moving out of the way. I mean, technically this one here isn't a fluid sim, it's just a compute shader. Which ends up, you know, as a render target. I mean, this is the interaction bubble render target. Which is what these guys are using. So you can see me creating this little trail. So this is what like some of the bushes are reacting to, and then there's like the wind stuff and the water stuff. So if I go to the water, and we start swinging through the water, and you can see, you know, we got water doing water things. Oops, I fell off. And then wind doing wind things. What does the map you use for the materials? Yeah, exactly. So the fluid sim or the compute shader outputs to a render target. And then the materials sample this just like they would any other texture, you know, like a noise texture or a color texture or whatever. Yeah, it's like really performant on the material side of things to just read from these render targets. So that's kind of what I'm filming this video about at the moment. Is how to set up the most basic of, you know, Grid 2D particle simulations. Where we're just going to get some balls and we're going to draw their locations to a render target with like a soft fall off and then fade it out over time or something. Or maybe make them blur. So where was I actually at in this video? We had the thing, we had the... Right, we had this, we had the arrays, and we were saying... We got the temp balls value, add that to temp balls, then set final color as temp balls. Oh, good, Paul. Have a good one. Hope you have a very good one. All right, so before we start sending our balls information... Oh, am I blurry? All right, so before we start sending our balls information into these arrays that we've put... that we've hooked in, we first need to actually set location, ball, and radius array here, and velocity and strength array here. So now the balls are gonna do their thing. It says, draw the balls, temporary balls was red before being set. Default mode is fail if previously not set. This is a very common error, so I will show you how to fix it. It just means that this variable here is null rather than 0. Or like it just doesn't know what the fuck it's doing. So we're gonna go to parameters, local, module locals, click on temporary balls, and then up here, instead of fail if previously not set, we'll just set it to value, and it'll just be 0, 0, 0, 0, and now it's happy. You can also do that with these values here, like if we were getting, you know, final color, and adding it and setting it over here or something, it would be throwing an error as... Oh, you can't even fucking see it. You can also do that with... you know what, fuck it. We'll get to that when we get to it. Kill myself. Alright, so this should all be set up, ready to receive the balls. Now, how do we actually do this? So my preferred method for sending data into a kind of shared simulation space, like our ball grid, is to use a manager actor, or a manager subsystem, or a manager component, whatever. For the time being, we're just going to use an actor. So this is called just regular actor, Grid2D tutorial. Why is that in all caps? Caps lock. Grid2D tutorial manager. And let's just go and get our Grid2D system that we just chucked in the world. We're going to delete that. And we're actually going to put it in the manager. So let's go to our event graph. Let's just add a Niagara system. Niagara Particle Component System. This is called our ball simulation. And we can set that as the root by just dragging it up. So now we don't have that scene root component being pesky. And in ball simulation, we need to set it to be our tutorial Grid2D tutorial system. Now you can see in here, we've got those default variables. So we've got texture render target. Yep, we already set it in the Niagara grid. We can set the grid resolution here if we want. And then we also have these arrays of ball location and radius. Just leave them. We're not actually going to touch them. You know, we don't care about their default variables. We care about where are the balls. So, the way I like to do these things is we're going to create a new function. This is called receive my balls. Receive my balls. And then this... Oh, fuck's sake. And then this needs an input for... Oh. This will be a vector 4, because we're using vector 4 arrays. Where the hell is vector 4? Vector 4. So this is our ball location and radius. And then we can just duplicate this guy. No, we can't. Can I? Fuck it. We'll just make a new one. And this is called ball velocity and strength. And we're actually going to make this... We're going to make both of these arrays, because you might have some actors that have multiple balls that you want to send in. So we're going to also make a variable called... This is, again, another vector 4. This one's called balls location and radius this frame. And this will be a vector 4. Why, you guys can't see that, can you? Let me put that up. Yeah, okay. So this is balls, location, and radius, this frame. And this is going to be an array. You can change this to an array by shift right-clicking. Fun fact, fun fact. We learn something new every day. And then we're going to make a new variable. This is called balls, velocity, and strength, this frame. Cool. So, when we receive a ball, this is like a request from a ball to be drawn to our render target. We are just going to get whatever it's given us. We're going to append. And we're also going to append this bad boy. And we are appending this array to this array. And then we're going to do that here. And that goes in there. Cool. Compile. Sweet. Okay, and then we've got the receive my balls function. So anytime a ball wants to be drawn, it's going to call this function on the manager and be like, hey, draw me, draw me, draw me. We could, again, this might get a little bit complex, but there are different methods. You can either pull data from a list. So, for example, you could have a list of all of the registered balls, and you could ask them, where do you want to be drawn? Where do you want to be drawn? Where do you want to be drawn? Or you could put the balls in charge of it, where the balls are telling the manager, I want to be drawn here, I want to be drawn here, I want to be drawn here, I want to be drawn here. That's totally up to you. We're going to be pushing the data in this case just because it's a bit easier. You don't have to fuck around with like registration and unregistration. So let's make one more function. This is called send balls to Niagara. And what this is going to do is we are going to get a reference to our ball simulation. We are going to set array, set vector for array. This is called, I'll have to double check what the frick it's called. Ball location and radius. Ball location and radius. And then we're going to set one more, which is called ball velocity and strength. And we're going to get the location and radius this frame, smack that into there. We're going to get the velocity and strength this frame, smack that into there. Make sure that is referencing that system. And then, very importantly, once we've sent this into Niagara, we want to clear both of these arrays. Clear and clear. So we clear our balls. And that just means that during the frame, during the game thread frame, we're going to be just getting a bunch of requests from balls to be received. And they're just going to add themselves to these arrays. And then we're going to send, whenever, you know, the manager ticks, it's going to send all of the arrays into Niagara and then clear the array. And then if for some reason, you know, something else wants to send a value, it will then get sent. How do I even fucking explain this? So that way, because we're clearing these immediately after they're getting sent, as soon as another value comes in, we can kind of guarantee that everything's going to be processed no matter the order of operations. Ideally, you should probably set the default tick group. Where the fuck is it? Tick group to be just post-physics, so that if everything else is pre-physics, then, I mean, they should all be... You know what? Let's just set our manager to be the very last dude. in the very last tick group. And then all of our components that are going to be getting the ball locations, they're going to be ticking post-physics because we want them to have moved, then set, you know, they've gotten their new updates and whatever. Hello, Lady Cat. Yeah. Where are you going? Come on. Yeah. Nope, she's gone. She's gone. Okay. So, last thing to do, let's just go to our event graph. We go to tick, and every tick, we just want to send balls to Niagara. That's all. That's literally all we want to do. Let's not worry about, like, turning this thing off or anything like that. We don't care. So, let's get our tutorial manager grid dude just sitting in the world. Doesn't matter where it is. And then let's just make a new actor called The Balls. Well, the ball. Yeah, the balls. Plural. So, in The Balls, we need to have a sphere or a whatever shape you want your balls to be. I won't judge. It's a sphere. The material doesn't really matter. Let's just go to the collision settings just to make sure that this will actually collide. Block all dynamic, that's fine. Simulate physics by default set to true. And then let's just do on begin play, get actor of class. We're going to look for our manager. Grid manager. Grid manager. Grid2D tutorial manager. I'm going to promote that to a variable. Let's just call this the manager. And then we're going to ask, can I speak to it? And basically on tick, manager, we are going to receive my balls. We are going to get our sphere. And because this is just a singular, singular sphere per actor, we're just going to go make array, which is just going to make a single, well, you can add extra pins to it if you wanted, but we're just going to do it as a singular for now. We can break this apart, split the struct pin, and then for the sphere, we are going to go get location. We're going to break this apart, X, Y, Z. We'll just set the radius to be, I don't know, 40 or something. And then the velocity is going to be get velocity. Get component velocity, which only works if it's simulating physics. If you did want to do this with non-simulating entities, you need to like manually calculate their velocity by getting their current position, saving their previous position at the end of each update, and then subtracting the previous from the current to get the current, multiply by delta time, something. Figure out how to do velocity yourself. But luckily for us, we're going to be simulating our balls, so that's just X, Y, Z, and the strength value is just 1. And so on tick, we send our balls data to the manager, and we can have as many balls as we want, and it should be sending it into our Niagara Grid system. Now, these might be a bit too big to ball, but I'm not sure. Now, these obviously aren't going to be ticking right now. However, if we do hit simulate, nothing happens. Now, why is this? Well, I'm not sure. I'm too dumb. Let's just make sure this is Grid2D tutorial, dude, blah, blah, blah. Receiving balls, the manager. We're appending this guy to that, and then that to that. Sending that to Niagara. Ball location radius, ball velocity and strength. Could it be... I don't know if you need to specify user or not. Let me just check if my draw the balls is doing that, then it goes into there, then into there. Okay, let me try user. I don't reckon I've... yeah, you know what. And let me just double check that I've... Ball location, radius, ball velocity, and strength. Set vector for array. Still nothing. Why are my balls... Alright, debugging time. Stop the recording. Let's just get our debug ball, singular. Aha. Okay, what have I done wrong here? Temporary balls. Temporary balls. Temporary balls set as final color. Is final color not our... What to draw to duffing? Final color. Is it because this is auto playing? Let's go to our manager. Grid2D tutorial manager, ball simulation. Okay, it isn't getting its data set. Wait, interface array float 4. And that would just be all of the things. So why are they not getting sent in? The manager. This is ticking. Send balls to Niagara. User ball location and radius. Ball's location radius this frame. We're not getting errors. Lady cat. Oh, I bet you it's like a different... Hmm. Because it used to be like an object. You'd set the Oh, nice. That's get vector for array. Set vector for array. That is the correct one. Array data. Let's just not clear it. Are the balls ticking? Are you ticking? Tick. Start with tick enable, blah, blah, blah. Oh, you know what it could be? It could be the Niagara Grid. Niagara tick. Oh no, use prereqs. Does it? It doesn't need to... Oh, you son of a bitch. It doesn't need to use tick. Tick time for the balls. Well, the balls should just be doing pre-physics update. Hello, my girl. Hmm? Hmm? Are you good? You're a funny ball. You're a big bowl of fat. What a blurry cat. Yeah. You want to go outside? You want to go outside and hunt bats, and rats, and cats, and birds, and mice, and lizards, and frogs. I think she wants to eat everything. Yeah. Yeah, come here. Let it go. Hello. Ooh. Alright, we'll take you outside. Alright, Kashmir Saha Baudaya. Let me just run an ad and I'll let these cats outside again. Oh, up she goes. Come on. Hello, I'm back. This has been a Niagara side because the test ball location should be... Yeah, that's what I was thinking. That's what I was thinking. But we will exhaust all options. So let's go back to here. Draw the balls. That is going once. Data interface. Doing the thing. Let's just check our resolution. Yeah, 512. Cool. It could be that the map 4 is just a bit funky. I'm getting length, ball location, radius. If I just say iteration count 1, hard-coded. Because it could be that it's iterating 0 times. So now it's iterating once, and it's doing its thing. And then, yeah, so it's spitting out. So it isn't that. So then our arrays, they are getting from the current index. So now if I put these back in. Oh, wait, is that just what happened, though? Was it? No, I just put them in before, right? To test the thing? Yeah? No? Yeah. So, yeah, let's just send in some dummy data. I've got about Grid2D render target via Niagara. I want to make a render target with multiple dots that gets position from actors in the map. Use it to post-process to have an effect on those positions. That is exactly what we're doing right now. So, you could go through this VOD and do that. You know, do it that way. Or I'll be editing this into a proper video soon. Like within the next 2 weeks. There's a video I want to do this week, which is just custom Niagara functions. But then I want to do it, and then, yeah, that once that's released, then I can release this video. Okay, so let's just go to the manager. And we're not clearing the arrays now. Let's just set location and radius this frame. default variable. Let's just put one in that is 0, 0, 0, 100, and then this can just be 100x and 1 strength. And then we're never gonna clear them, and then let's just unhook the receive my balls. So this should just be drawing a red dot in the middle. Cool. Okay, so it is doing it. Oh, wait, is this the array to add the source array to? Ah, the array to add to the Okay, so the reason this wasn't working is I have my appends around the wrong way. So this is the source array, and we want to append this to it. And then here, this is the source array, and we want to append this to the source. Append to the source. Okay. So, with that small change done, we're sending these in to our Niagara dude. We're clearing them as soon as they get sent. Our balls are sending in their information on tick. Let's just also, in class defaults, set their tick group to be post-physics, you know, kind of makes sense, just so they're more up-to-date. Then, if we make sure, you know, our things are hooked in, we're doing the iteration count by the length of the arrays, we should see the balls. Are we ready? Let's do this, and then play. That's not simulate, that's fucking play. Okay, you know what, let's just... What's simulate? You fuck. Alright. Alright. So, with all of that set up, does it work? Okay, look, yeah, they're drawing negative values there, but if they're moving in a positive direction, then you can see that, yes, they are drawing to the render target, which is really cool. Very good, very good, very good. So, just for debugging purposes, because we are working with negative values, because we can move backwards in Y space, let's just go to our little test material guy. And we are just going to get the output here. We're going to add 1 and divide by 2. And that's just going to put the... what's it called? It's just going to do a thing, you know? Just trust. So, green is that way. Purple is that way. You know what? You get the point. We can just... I did hit record again, yeah. So you can see now, we've got the balls. They're drawing a bunch of different colors as they move, and that's fantastic. Now, you may notice... well, okay. Here's the cool thing about it, right? We can just add more and more balls, and our Niagara system just does not give a frick. And we will also... Let's just increase the radius of what we're drawing. We'll go 75. Why not? Or maybe let's stay at... You know, let's go 75, and we will also... reduce the size of the balls. Let's just go to our sphere, scale, 0.5. You know, just so we can really see what's going on. So we hit simulate again, and you can see our balls are doing bally things. They're drawing their velocities to our render target. Everything is awesome. Everything is cool when you are part of a team, but also when you're not part of a team, everything is also quite awesome. And we can just keep adding balls. We can just keep adding balls, and our system will handle it. How do I... There we go. I'm also just going to make the thing a tiny bit bigger. Yeah, dank. Yeah, I could just get the radius, but YOLO. Okay, so you will notice that our balls are, well, they're not really leaving trails like I said they would. You know, they're kind of just, sometimes they have circles around them and whatever. It's just a bit fucked up. So what we need to do is in our grid system, here we've got one called Draw the Balls. What we may want to do is instead of doing these straight to our final color, let's actually change the name of this bad boy called the Balls Input. And then in another stage, we're going to add the Balls Input to the final color. And then in the next cycle, we're going to add it to that final color again and again and again and again and again. So let's go new stage, simulation stage, generic simulation stage, iteration source is our data interface. The data interface is the tutorial 2 grid collection. We're going to put this one in the middle. We're going to name it draw. Let's just call this the whole thing. Maybe. No, let's call this the No, there's probably a better way to explain this. The Ball's tail. Wow. Yeah, I'm just trying to think how to keep this as simple as possible, but maybe this is the right way to do it. Yeah, actually, we don't need another simulation stage. So, if we wanted to draw our balls as like a trail, a persistent ball trail, we're going to change this to Balls Input. We're just going to add another stage at the end here. And this will just be, again, another scratch pad. And let's call this add input to sim, I guess. Firstly, again, we always need our Grid2D collection. Let's just get the variable straight up, so vector4. This was called our balls input, and we can just get it from stat context, you know, as long as the name is the same. And then we're gonna get our vector4 final color. Again, this can be stat context if we want it to be. And we are just going to... You know, we don't even need the Grid2D collection, technically, because we're just saying for this pixel, get balls input. Let's grab delta time. So, balls input multiplied by delta time. Also multiplied by some, like, you know, input factor. Leave it at 1 for now. Then we're just going to get the balls input per second. We're going to add that to the final color. And then, technically we don't want to clamp it. Let's just chuck it in. Let's just set new final color. Stack context. Apply scratch. Compile. This might give us some errors. No, it's pretty happy. So that is balls input, final color. Okay. So now in this stage here, remove. So now, oh god. So now in this stage here, we are just getting the balls input that we calculated earlier. We're adding it to the final color. And then on the next frame, we're just going to add it again. We're going to add it again. We're going to add it again. Whoop-de-doo. So now you should see we are drawing persistent ball trails. It's a little bit confusing because the radiuses are so big. But They're just drawing their velocity to this map over and over again. And, I mean, that's all there is to it, right? Let's just scale the radius down slightly. Now, you might notice that... Now, you might be noticing that we used to have, like, a kind of soft fall-off for our balls. However, these seem really, really hard. Now, the reason that they're really, really hard is that we're actually drawing... How do I put this? The reason that they look really, really hard is that we have this soft fall-off, right? So this is 0, and this is 1. But we're then multiplying it by velocities that go up into, you know, the hundreds of units. So we're like, you know, draw green 100, and it meets way up here off the screen. So it kind of just looks like it's a really hard edge because we can only see 0... Pardon me. Because we can only see 0 to 1 in our debug texture space thing. So if we actually went to this material and, you know, got the render target and just divided it by, I don't know, some max velocity value, 200, then you will see that we have the soft fall off back. Maybe a little bit too soft, if you ask me. Maybe just divide by 50. Good enough. Yeah, cool. Okay, so now we have our soft fall off, but we have real values in our simulation. So this is like the actual velocity, and you know, in the very center of our ball drawing, the velocity is like the true value, and then it just drops off, you know, with the feathering towards 0. Okay, cool. So we now have something going on. We're drawing the location and velocity of our balls. And they are drawing trails, which is great. But we may want to... But we may want to do something a little bit fancier with what we're drawing to the grid. So let's just make another simulation stage. And this is also a very important part of... we're going to call this trail decay. So this is going to be like a very important lesson in Grid2D. We are going to execute data interface, our Grid2D interface, and we're going to make a new Scratch module. And we need to get our Grid2D collection. And what we're going to do is, over time, we are going to blur our velocities, our render target, and also dissipate the values back down to 0. So what we'll do is grab our execution index to grid index, and then in Grid2D collection, we are going to use get previous vector 4 value at, well, this would give us, you know, basically the same value that we want, but we can do, also let's just get the final color. But what we want to do is get the up, the down, the left, and the right values. And so what we want is we want the original Y value for these two, but then we want to add 1 convert to int, and the 1, and then we want to subtract 1. Oh god, this is messy. Let's just yeet all this over here. So x plus 1, x minus 1, and then we want to do the same for the y down here. So original x value for these two, but then y plus 1, y minus 1, and then just chuck all these grid inputs into here. Sweet. Now this looks messy as hell. You can clean this up somehow. I swear it's possible, but we don't care right now. So let's get our surrounding values, and then we're going to set the new vector for color as our final color. This will be stack context. And we're just going to get all of these ones. We're going to add them all together. And then we're going to divide by the number of things that we're adding. This is also known as getting the average of some values. I'm going to chuck that into there. Now, keep in mind, when it says get previous vector 4 value, it means that it's getting it from the previous stage. So after this stage, the values all get cached. They get written to a temporary buffer. And then we can access all of those values and set a bunch of new values without affecting these ones. Because if you think about it, let's say this is our grid, and we were doing an operation where we want to get the average of, you know, we want to get the surrounding pixels or surrounding particles, and then set the new value as the average of its surroundings. If we were actually updating those values in place, then there would be like a really weird bias towards the top left, because, you know, we go through this one, and we go through this one, blah, blah, blah. We get this one, we change its value, and then when we update this guy, well, these ones haven't been updated yet, but these two have been updated. And so, you know, now our calculation isn't really going from the previous frame to the next frame. We've kind of like bastardized... bleh. We've kind of bastardized these two values, and they're no longer accurate. So we essentially just save a copy of the whole array, and, you know, let's just think of it as being like behind this one. And so we can, for this value, get, you know, the one above, the one to the left, the one below, the one to the right, but from the previous stage, you know, kind of backwards a dimension. And that way, everything has, yeah. And that way, you know, we're not pulling from some values that have been updated and others haven't been updated. The other reason for this is that GPUs, they do everything in batches. So most GPUs will update our particles in 64 operations at a time, like 64 particles at a time. And obviously, like, you know, for these ones over here, like... And so, obviously, if it's doing them all in parallel, each thread doesn't have access to the other ones as they're getting updated. It's just all fucky. So, anyway, long story short, everything gets cached, and then when we go get previous value, we're reading from the cache to make sure that we're, you know, not pulling data that's, like, just been updated for this pixel. It's all a big batch operation. Big booty batches. Alright, so Scratch module, let's grab our Grid2D again. You just grab it here, Grid 2D collection. And just to recap, we get the up, down, left, right, and add them all together. You know what? Just for good measure, we could just get the one in the original spot. And add it as well. Let's just do it down here. add that and divide by 5 instead. And then keep in mind that this is like frame, you know, this, keep in mind doing a blur like this is not frame dependent, or sorry, it is. We're basically just doing this operation once per frame. It doesn't actually care about, you know, the frame rate. We could get around that by, I don't know, doing like a lerp, and the alpha could be delta time. Chuck that into the alpha, and so 0 is our original value, and B is our blurred value, and you could get like a multiple of delta time or whatever. We're just not going to worry about that for now. That's just a bit out of scope for this tutorial. But if we now look at our balls are doing things, and they should be blurring out. It's very hard to see, but if we look at this guy, you can see that, yes, they are slowly blurring and blurring and blurring. You can see here, this is just kind of, you know, they're all bleeding into each other. It's just blurring over time, which is really good. One other thing we'd want to do in here is just multiply this by, you know what, let's just get delta time. Get the 1 minus of delta time, and so this will be like a value very close to 1, and then we're just going to multiply this by that. So again, this isn't completely frame independent, but it's close enough. So we're going to multiply this by the inverse of delta time, and therefore they will fade out pretty much over 1 second. And obviously blurring out in the process. So there we go. There's some funky stuff that we are doing. Let me just add more balls. Cool. It's magic. We have lots of balls. There. Sorry, I was just replying to a message. Okay, so what were we doing? Right, we've got balls. Balls are drawing stuff. It's blurring out over time. Really cool stuff. Really useful. Whoa, that's so useful. Well, actually, no, this is kind of useful, right? Because we could do a grass bending implementation. Maybe we should do that. Okay, so we have balls. At least 50% of us do, anyway. Did you guys know, by the way, the average person in the world has less than 2 balls? Think about it. Because if even, let's say like half, like exactly 50-50 people in the world, 50% of them have balls and 50% don't. But then of the 50% that have balls, if even one of them has only 1 ball, then the average person has less than 2 balls. You know what I'm saying? Well, I mean like the average person that would usually have balls. Well, actually, no. Technically, the average person has less than 1 ball. If you account for, like, the entire population. Because if half the people don't have balls and the other half would usually have 2 balls, if even one of them, has only 1 ball, or lost their balls, then we all have less than 1 ball. Isn't that weird? There you go, fun fact. There's our statistics for the day. Oh look, there was the. Okay, so maybe that will make it into the video. Well, okay, if some people have 3 balls, then that would probably even it out, you know. We saw that. You saw that? You saw that? That was. Is that deterministic? It is deterministic. Yo, deterministic physics proven in Unreal Engine? Okay. Sorry, enough ball talk. What was I... Ah, okay. So, we've now successfully drawn a bunch of ball locations and velocities, and they are fading out over time. We're drawing them to this render target. What does that mean? What does it mean? What can we do with this? So, as an example, we could use this velocity drawing thingo to do some very basic grass interaction, right? We could get a... shit. Fuck. Alright, you know what? Let's go. Foliage. Let's do... Okay, material. This is called grass interaction. For our grass, we are just going to use cubes. Or maybe planes. Maybe we could use planes. So let's just go to foliage tool. We're going to add a new... add foliage. Oh, fuck. Static mesh foliage. We're going to look for cube. Cube? Fuck's sake. Alright. Let me just get rid of all that stuff. What are we doing? Not much. Not much. You? Sorry, I just need to look for cube. Cube. Oh, you know what? I've got my Prismatiscape ones. Fuck it, I can just use them. Demo example meshes. Alright. So, for this, I'm just going to use these very generic tree saplings from the Prismatiscape project. And I'm just going to paint... I don't know how many. How fucking many that is. No, maybe more. I'm just going to put the density up to 10,000. And the scale 0.5 to 2 and just go boop. And then I've got all of these meshes here just chilling. It's quite a few of them. Sweet. And then... Oh, sorry. And then, in our material, grass interaction material, this is getting really messy. We are just going to sample our tutorial render target. Grid tutorial render target. The location is going to be... Again, you would use something like a material parameter collection to do this usually, but in this case, we are just going to do subtract. Well, we're going to get the text coords of our plane, which we know is 512 units long, so we're going to get 512 divided by 2 and subtract that number and then divide it by 512. Actually, no, I don't even... Maybe? I can't remember. How does this work? Oh, frick off Epic Games. Let's chuck that into the base color. So this would get text coords... No, I want to do it this way. I want to divide text coords. Hold on. I can do this. We want to get world position, XY, and then we want to subtract this number, and then divide by this number, and that will give us the coord. So this is the size in world space of our thingo, and this is the top left corner location of our thingo. So we're just going to chuck that in there. And then I'm just going to go to our foliage and override the material. Override materials as this guy. Now I can just yeet out of here. And yeet out of here. Technically... Yes, okay, so you can see on our grass or our foliage or whatever the frick it is, they are all inheriting the color. So that just means we've sampled it correctly. You know, actually, I just want to make them a bit smaller so that it's less hard to see. PO. So 0.5, and then delete this. And then radius paint. Okay. Alright, I went and made them a little bit smaller, but you can see here that our little meshes are inheriting from our balls, or they're inheriting from the kind of render target underneath it. So, again, we only know that because we have a fixed position in world space, but these should be parameterized. That's on you, not on me. Then, what we can do is, let's get a rotate about axis. Rotate about axis. The rotation axis is going to be mask XY. That goes into there. The pivot point is going to be object pivot point. Mesh particle pivot point, okay, blah, 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 blah. The position is world position. And the rotation angle is going to be the length of our xy velocity divided by some offset value, saturated. Let's go to like divide by 20. So if they're moving at, pretty much if they're moving above 20 units, or if the velocity being drawn, oh, I'm not even fucking recording right now. Hold on, that was like just after I made these all smaller. Oop. Okay, so I've gone and made these foliage meshes a little bit smaller, just because they were kind of, you couldn't really see what was going on. But in our material, we are going to use a rotate about axis node. The pivot point is just the origin of the mesh, so that's like the root of the, you know, the little foliage dude. The position is the world position. The rotation angle is going to be, so essentially if the velocity that we're drawing is any greater than 20 units per second, we want the value angle to be, let's see, rotation angle. So this is a 0 to 1 angle, not a 360 degrees angle. So 90 degrees, aka splat it down on its side, is 0.25. So at 20 velocity, make it go 90 degrees, make it fall on its side. And then for the normalized rotation axis, that is going to be the direction, the velocity direction. And we're actually going to normalize this because technically we don't have, well, technically, yeah, it isn't normalized. So we should be able to just put this into the world position offset and see some funky effects. Firstly, what we'll do, we'll just add and divide this. Just divide by, I don't know, 20, whatever it was in the other thing. Oh, no, wait, no, sorry, I want to divide. Add divide by 2. Okay, and we just want to remap the color so that it kind of matches that plane that we had underneath our foliage. So, you can see right here, we have a divide by 0 error, which is, you know, probably not what we want. But you can see we have some movement going on, and it's kind of going in the wrong direction, which is great. I think the divide by 0 is happening because, well, the rotation axis is 0. So let's just really sneakily append vector. We're just going to append a really, really small z value to this guy and put that into there. And hopefully this fixes that, yep, that divide by 0 error. And now you can see the foliage is moving out of the way. It's moving in the wrong direction, funnily enough. But yeah, that's an easy fix. So if I move this ball around in world space, then we want it to be affecting the foliage. So I think what we need to do is just we got to swivel. No, swizzle. I think it's called swizzling. So let's just break a 2 vector and make a 2 vector. And it's something really dumb, like flip the x-axis and plug it into the y, and then plug the y into the x. It's something like that. I don't know. Okay, we almost had it. That looks about right, but it's just that they're both... Okay, that one's just negative, and that one is just negative. So, it's actually the positive... this guy and the negative this guy into there. Okay, that should be it. That's how we swizzle it. You could also just do, you know what, why didn't I just do this in the first place? You can just cross it against the up vector. But, I don't know. This is probably cheaper because it's just... Yeah. Okay. So now, we hit play, and you can see all of our little squishy dudes are getting squished in the direction of our balls. And then they're all recovering because we're doing that blur and subtracting the value over time. So this is like a very... This is pretty much the Prismatiscape plugin. So if you've already bought Prismatiscape, then you got scammed. You got scammed because this is all it is. As you can tell, because this looks just like Prismatiscape, right? So, yeah, look, this is the very, very basics of Niagara Grid2D. What it can be used for, all that kind of stuff. We could go one step further and, you know, do a fluid sim for, you know, these balls. But that's a little bit out of scope for this video. However, we will visit fluid dynamics in a follow-up where we're going to be taking this little system here, again, just with a hard-coded position and all that kind of shit, and we're going to use the velocity that we're drawing to create wind. We're going to... And then the wind and all the wind, like, hits each other, and it's going to be great. And it will end up looking something like... I need to plug my latest invention. Yeah, texture pool these nuts. Pool these textures. Pool these. Where's the schwinger? I've got the schwinger going, but I think it's a... Cell size is 1. Okay, so that should be... Right, but the vortex is just too fucking strong. Okay. Okay, that's not very vortexual. And, you know, I'll put the... What's the pill doing? That's just doing a big, yeah, big explodey boy. It's a little bit too much, though. Do these ones still... They are hitting each other, yeah. And they're going too far up. I just want, like, a good example. You know what? I'll just do vortex, but, like, strong. And so at the end of that video, we should end up with something similar to this, but in 2 dimensions and not just doing a spiral vortex, but it'll kind of have these properties where we have like these nice little curly whirlies and things look like they're like moving around like an actual fluid or a gas in the case of our, you know, our balls simulation. So I hope you're all looking forward to that one. And it's probably a lot simpler than you think it is. Especially once you've got the inputs sorted. You know, once you've got our balls drawing to the simulation. It's actually really, really easy to then take that and turn it into, you know, a fluid simulation of some sort. So, hope you're looking forward to that one. Let me just go back to our fucking thinger with the schwinger. There you go. And projecting it to the world. Exactly, exactly. I need to hit simulate, don't I? One last thing before we wrap things up is you can see that outside of the bounds here, we're kind of getting tiling. So you can see that this guy here is affecting, you know, over here and up here. That's a pretty easy fix that just needs to happen in the material. Not the oh, fuck you. Fuck you, dog. Here you go. And all that we need to do is we just need to pretty much anything that is outside of the UV space, we just need to mask it out. So what we're going to do is we are going to floor our UV space, which means that anything that's, you know, above 1 will get floored down to 1. Anything that's within our UV range is going to get floored down to 0, and anything below that is going to get floored down to -1. Then what we can do is absolute that, and then saturate it, and now we have a mask of the... what's it called? And so now we have a mask. I can probably just show this in the material. No, it's kind of hard to show. So now we have a mask. If I... let's do it over here. Let's just break 2D. So hopefully we can see our little grassy boys. So if I just get the mask here, this is in the R direction of our UVs. So you can see over here. Oh wait, why the fuck are you white? Oh, I floored it, and it's this. Why is that white? Eh? Doesn't make sense. Hold on. Let me figure this out first. Tell me the RT texture fixes that. Clamping it would make it so that the edges repeat infinitely. It won't actually make the edges go down to 0, unfortunately. What's wrong with my math here? R value. Show me the thing. This should go... oh, right. No, this... am I supposed to be... no, that's correct. What have I done? I think I'm supposed to add this value. Because otherwise, yeah, okay, that's... it ends up being correct when I subtract it. Okay. You know what? I need to pee real bad. Let me... I'll be right back. Fuck, I wasn't... sorry. I'm so dumb. Alright, let me stop recording. I wish I could hear him as well. Alright, new recording. Okay, so it turns out when I did the, offsetting the corner to the center, we actually wanted to be adding half of our, resolution in world space thingo. The reason that this did work, when we're looking at our balls, was just that the UV's tile, but we actually want to get the proper UV space because we're going to be masking based on the UV space. So if we floor our UVs, then anything outside of our UV range gets clamped downwards. So anything between 1 and 2 will get set to be 1. But anything within our UV range, our proper UV range, within 0 to 1, will get clamped down to 0 or set down to 0. And then anything below that, slightly outside of it, will get set to -1. So now, after doing this, all of our desired values are at 0. So we want to get an absolute, which is just going to bring those which is going to get those negative values and yeet them up to be positive. Again, all of our desired values are still at 0. Then we're just going to saturate this to make sure that, we're not getting any big-ass values and whatever. Then we're just going to 1 minus this, which is going to flip our 0 to a 1 and our 1 to 0. And then we're just going to break float 2. So if I actually just get the R value and put that into base color, then you will see that all of our stuff, in the middle is white and everything either side is black in our X direction. And then if we look at the G channel, everything that is out of bounds in the G direction is black. And then we can just multiply these together. And we now have a beautiful UV mask where, based on the UVs of our little simulation, we're just going to ignore everything outside of that. So we're not going to get that weird tiling, where a ball was interacting here, but it was affecting foliage over there. So we can just multiply the output of our texture or our simulation by that mask. Now, you also could do, and this is especially, the case with like the Prismatiscape plugin, for example, where... Now, in the case of something like Prismatiscape, where, the simulation is moving around with the player and extending out, into the distance, you kind of want to avoid pop-in. Like, you kind of want it to fade in as you move over there. So, one thing that you can do is just get our UV and do a, radial gradient exponential. The center position is just 0.5 if this is our UVs. Radius is whatever the default is. You can pretty much just grab this, chuck that into there, and that will just do a little circle mask. And it will also mask out things, that are out of bounds, coincidentally. So we just hit simulate again. You can see that we've got all our stuff, but it will fade out. Well, at least our interaction will fade out towards the edges. So you can see here, if I just like zhuzh all these around, you can see that, there's kind of a circle of effect where they aren't being affected. So that kind of just reduces... So that just sort of reduces pop-in, if we were moving through the world. and our simulation was following us, then it would kind of like smoothly lerp in to the interaction effect. So that's just some little extras that will be relevant in the future. You could also do a box mask by like, oh god, getting the getting the UVs, chuck it through a sign with a period of 2, and then multiply that by whatever the hardness value you wanted, and then saturating that, and then breaking those values out, and multiplying them together, and then you'd end up with a kind of soft box, where you've got, you know, here, but then you can see these guys. Yeah, bleh, there we go. So this is like, so this one is kind of like the radial effect, but it's actually like more squarular, and also cheaper, and you kind of waste less of the simulation because, you know, you see more of the corners. So this is what I prefer in my personal project because it's a top-down game and we can look up into the corners, so it's better to just make it more squarular than circular. But if you're doing like a, you know, a first or third person game, then you might want to opt for a circle, a 2D sphere. So there you go. Just some little extra doodads for your viewing pleasure. I think for now we just want to yeet that in. So there we have it. You have now mastered Grid 2D. If you can get to this stage, you know, with the help of this video, you are pretty much on your way to becoming a fluid ninja. Sorry, you are on your way to becoming... So there... Oops, sorry, let me restart the simulation. So there we have it. You now have some very basic understanding of Niagara Grid 2D. We have converted, you know, the grid space into kind of world space. We're now drawing world space locations and radiuses to our grid. We are drawing, you know, an X number of balls to a grid. We can delete a ball and it will just stop drawing to it, and it's absolutely happy with that. You know, it doesn't give a fuck. We can just move these around. This one's drawing stuff. Boop, goodbye. And it just doesn't care. We can just keep adding more balls if we really wanted to. We've implemented our simulation into a shader. Again, with like a fixed position, but, you know, we'll talk about how to actually move the simulation around in another video. Maybe. Or yeah. Yeah. And, you know, this is just, look, it's fun. It's fun, and it's cool, and it's good, and it's groovy, and hopefully with this knowledge, you can figure out some really cool systems that you could implement into your game. For example, you could use this for a fog of war system. You could use this for foliage interaction. You could use it for wind simulation. You could use it for some really cool magic effects. You could use it for doing minimap stuff. You know, cool advanced minimap effects. You can even use Niagara Grid 2D simulations as like rendering passes. You know, you could iteratively blur the screen for a post-process effect or something. Or like do like blur trails or like that kind of, you know, in Call of Duty, and he's like, Mason, what are the numbers mean? You know, the numbers, what do they mean? And it's like all blurry and trippy, and there's like, you know, you take the previous frame and you fade it out over the current frame. You could do that in Niagara Grid 2D, basically. And I love Call of Duty so much. It's my favorite video game. The number is that, what one's that? Is that Black Ops? I think I remember my little brother playing that one. Modern Warfare 2 gang for life. Xbox 360 era. But there we have it. Niagara Grid 2D. An introduction. Ooh. So hopefully you've learned something in this video. If you did learn something about Niagara Grid 2D and you felt it was a sufficient explanation, you are legally obliged to like this video and subscribe to the channel for the future videos where we're going to turn this little ball sim into like a fluid sim. You know, those like cool fluid sims that like all do the swishy, swirly stuff. We're going to do that in the next video, and it's going to be fantastic. And then for other later videos, we're going to talk about actually, you know, mapping this to world space, how to like move it around properly, because it has to move in like discrete pixel steps to prevent sub-pixel blurring, all that kind of stuff. We're going to sort that out in another video, but that's out of scope for this one. If you do want to support the production of these videos monetarily, you can do so for as little as $1 per month in the Patreon, which is always listed below in the description. And with that, we say goodbye. Goodbye. All right, then I cease the recording. All right, I'm still streaming, by the way. Don't go anywhere, please. Please don't go. Please, I beg. All right, what's next? Do I just move on to the fluid sim video? I don't know. I could do the Decal easy first take. Actually, this is the second time I've filmed this video, but I feel like I explained it pretty well this time, even though there's like literally an hour. It's probably like fucking 2 or 3 hours of footage. Fuck. Probably like 2 hours. That'll condense down into like an hour video, maybe. Probably less. I think this recording was a lot more chapterable, where it's like we do one whole little section, do a little debug at the end, and then it's like, cool, we've got that working, on to the next section. We do that one, do the thing, you know. Is this... Why is this all orange now? Oh, right, the day... The time of day is ticking. Yeah, that's definitely moving down. Cool. Yeah, so do I want to do the fluidy sim stuff, or do I want to... I could do the decals video. Decal masking. You show volume of your clouds on. Yeah, that could be actually really handy for debugging the clouds, or even just rendering the clouds. Whoa. The cloud butthole. The butthole of the world's butthole is at 0, 0. Very high up. Marcus, what's more efficient, using Niagara nodes or HLSL? Same algorithm, or it ends up the same at the end? It all ends up the same at the end. It's the same with the material graph. where you use like a bunch of nodes, but it gets compiled to HLSL. Yeah. So I wouldn't worry about using the nodes and stuff in materials and Niagara. In Blueprint, like Blueprint nodes are like slower than C++, but in materials and Niagara, everything gets compiled, so you don't really have to worry about it too much. So data, how many different decals put in the same before Unreal starts to complain that having a decal render pass right? You can put as many as you want, really. And yeah, they do happen in their own pass. So, they happen in their own pass, but they can't be fucking instanced for some dumb reason. Even though, like, it's... You know what I mean? Like, they're being compared against the depth buffer. So why can they not just... Why can they not just be instanced? It's really silly. But yeah, it happens in the D buffer, which I have a video about, the debuffer decal D's nuts. Debuffer decal D's nuts. And yeah, so they get, the decals get rendered in screen space rather than per object. So like, let's say you had like 100 decals that were covering 100 different meshes each, then you'd end up rendering the decals. You'd end up rendering 10,000 decals. Whereas with a debuffer, if you've got 100 decals, they're just getting rendered against the depth buffer. So you're only rendering the decals, or you're only calculating the decals 100 times. Like once for each decal, I guess. Is a reduced number of decals? Well, yeah, it depends on what the decals are being used for. For some stuff, you can definitely get away with just using, you know, just material tricks. Nice, like, material hacks. Hacker man. But for some other things... something. I can't remember. I've lost my train of thought. Dump all this nonsense. You could DM it to me if you want, or you can chuck it in the On Topic channel, I guess. Oh, I'm addicted to balls. I can't stop. You have a color with your sim velocity. I'm just drawing the velocity to the thing and then fading it out and like slightly blurring it over time, but they're not actually advecting. So I'm just drawing the direction of the ball and then fading it out. And so that's how the foliage knows which way to bend. In this example, at least. If I want to spawn a particle on the boundary between the radius and the black canvas, is there a way I could pass this location data to the spawner? What have I got on the boundary between the radius and the black? Yeah. You can pass in values that don't even exist. You know, that exist outside of the simulation space. Like this one here is technically outside of the sim space, but it will still calculate the radius, you know? It'll say, what's the distance from this out-of-bounds point, and still figure that out perfectly fine. So you can't see chat on stream? Yes, I've just got it in my video filming setup because I usually have an ultra-wide monitor, but while I do videos, I switch its resolution so that what's it called? So that it's bigger. So it's more zoomed in. All right, what do we want to... Let's maybe do that decal video. And then... we'll do the decals video, and then maybe do the fluid sim basics video, you know? How would you handle having multiple sim grids, like with world partition going on? What's the easiest way to check what grids need to be updated by an actor? The best approach for that would be to move the grid around with the player, rather than having a bunch of different grids. That is, if you didn't need persistent data. If you did want to do multiple grids like that, then you would... Well, you probably run out of texture memory extremely fast. Yeah, but the best, the most efficient way is to move it around with the character, with the player's perspective. That's what I do in Prismatiscape plugin. So if I just like hit play, and I go to the render targets, and I just go to the deform grid. You can see here's my little footprints, doing footprint things, but you can see that, you know, we move off screen, or they move off screen. And obviously they fade out, you know, as they get close to the edge. So it's not like persistent, but there is some backtracking that you can do, and obviously you can just make this radius bigger and bigger, but obviously your result becomes sort of blurrier as it gets bigger. But yeah. That's usually the best approach. Low-res grids for all active wheel partitions and high-res following the player for cosmetic effects. Yeah, well, for something like... Again, it depends on the end goal. Like, what are you representing in the grids? Is it like... Are you just drawing something like, you know, wild animals creating trails? And then, with those trails that they've created, you know, you want it to be reflected in, like, the grass and maybe the dirt and stuff. For something like that, I would look towards more of a CPU solution. Or like CPU... how do I put it? So like essentially you would have... You know, you'd have your chunks. And you could then... You know, split this into like, I don't know, 100 by 100 or 256 by 256 or something. Or maybe even... Shit, what's... Is that even... No, this isn't divisible by 3, is it? What's like, any divisible by 3? Any, like... Fuck, I don't know. Maybe you just do it by 4, whatever. So let's say you've got a 1K render target. And each pixel is representing 1 meter. Maybe a meter's too big. I don't know. So you could split your world into chunks, and each of those chunks have 256 by 256, or, you know, represents 256 by 256 thingos. But rather than, this is on the CPU, rather than having an array with all values, just set to 0, where you're just wasting heaps and heaps of memory, you could do it so that there's a default value, which is 0, but then, for example, as an animal walks past, it adds a value to a map, and that map can be, you know, an index, like a coordinate, cell coordinate, to a value. So as the animal walks, or as the people walk, or whatever, they get their current cell coordinate. If it is in the map, then we get the value and we add to it. And then if it isn't in the map, because maps are really fast to look things up, you know, if you've got the key. If it doesn't exist, then add it to the map and increment the value. So that way you have like a sparse data set of the values that have been altered from the default number, like this. And then you've got multiples of these grids, and you can have a master render target, which is like a 1K by 1K render target. And then as you move from some threshold to another threshold, you just iterate through all of the values in like the surrounding, you know, maybe it's a 2 by 2 thingo, and draw them to the new render target and move its, you know, top left position to the new position. So that way you've got persistent data that's stored on the CPU, but it's sparsely populated, but you know the coordinates of all that sparse data. But then on the GPU, you just send through these coordinates and the new values to be updated, and put them in like a bigger array that contains multiple chunks. Does that kind of make sense? This is kind of how I plan to do, like with my world sim shit. If there's like melted snow around a campfire, that's how I would do it. I'd be like, okay, the campfire is here, cells within radius, you know, we have the default snow value, and then we deduct some snow value based on that, and then as more snow accumulates, you know, it changes these. How the heck can I interpolate time? Basically, when I use the time node to animate foliage and parameterize that and change its value, it goes all funky. It looks like it has a spastic moment. So what you're encountering there, let me just save this as like more grid stuff. What you're encountering there, I'll explain why that happens. So time is just, the time node is just time since session start. And most of the time, it's just traveling at 1 second per 1 second. And so, you know, if you did a sine wave to, like, wiggle your foliage or some shit, or you were panning a texture, you're just getting this value and, you know, animating it like this. Or animating it like this, I guess. But when you change that value at runtime, let's say I, like, instantly changed it from, you know, being multiplied by 1 to being multiplied by 0.5. It would do this and then start moving slower, right? Or if you lerp it, it's like doing this kind of thing, and then, well, it's bending and doing. Well, actually, no, it isn't bending. Yeah, no, it's moving to a different position, like this, that matches. You know, this is like speed 0.5. 0.5 times. And this is 1x. This guy. So this is what's happening, and it looks like shit because, yeah, your foliage has to, like, move backwards through time. And obviously, the longer your session has gone on, if you're, like, 100,000 seconds into a session, and you then lerp to, well, I guess you'd be lerping to 50,000 seconds in time, you've got to lerp through 50,000 seconds, and it just absolutely fucks itself. So the better way to do it, to avoid this, is to use a material parameter collection which manually increments time. Or so, you know, you could call it foliage time, for example. And it is saying, okay, on tick, we get our current foliage time thing. Foliage time. And then we're going to add whatever the delta is. Delta times speed equals new foliage time. And so what that will do is, if it's just set to 1, then it will increment normally, like this. But then if you want to slow down the wind speed or something, you instead slow down this variable, and that will just make it increment slower. You know? And then you can even, like, rewind it if you wanted. You know, you can make it negative. But it will all still work perfectly fine. If you wanted to do this with a panner, you would do the same, but in 2 dimensions. So you'd, let's say you've got, like, a wind noise texture that you're, like, panning. You would instead do, you know, an XY location. Like this. So this would be moving diagonally. And then maybe you want it to stop moving sideways. So this would then go like this. And this guy would just continue on, whatever. Kind of think of the panner as like a panner position that you're manually, you know, you're moving the texture around every frame on tick. So it can go like this, and then it can, like, go to the side and whatever. It can do that. It can end up back where it started, or it can just keep going forever. It doesn't really care. And, you know, if you then wanted to, like, stop the panning of the texture, then that's totally fine. It'll just stay in this position. But if you were doing it, you know, using the time node and a panner is just getting some XY value and multiplying that by time, and then adding that to the text coords. And that creates an offset over time, you know, and it looks like it's panning. But then as soon as you change time, you know, time is just time since session start. So again, you get that real fucky thing where if you wanted to change the speed in the middle, you know, during play, it would have to backtrack through hundreds and hundreds of seconds of panning to then reach that new point to then continue going slower. So that's my solution to it, and I'm pretty sure it's the only solution to it. Yeah. 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 So you might need to have, like, a bunch of different time variables. You might have, like, you know, wave time. You might have wind time. You might have cloud time. all that kind of shit. But you end up being able to move them all, you know, properly and set their speed properly. You can still, for example, you know, if you've got foliage time, which is for like the wind speed or the wind panning speed or whatever, you can still multiply the like you can set a multiple of the values, which will just, you know, end up looking like this. So you can make the trees sway slower than the grass. That's totally fine, but you can't change the speed of the tree relative to the speed of the grass, if that makes sense, without having two separate variables. So if you wanted the grass to go crazy and the trees to go really slow, but then you wanted the trees to go fast and crazy while the grass goes crazy, you'd have to have two separate variables. But yeah, usually just like a foliage wind speed ticker is enough. Or like a, you know, cloud noise panning location or panning offset that you're just constantly updating on tick. And like moving it around and slowing it down and that kind of thing. That's the way to go. Wind time. Nice. Cool NFT. Okay, what the fuck was I doing? I was going to do the decal masking video. Decal mask D's nuts. Let's just go back to this level. We'll go decal video. That's decal parallax video. New folder. Decal masking vidya. I need to pee real quick, so BRB. I need some water as well. My voice is getting a bit hoarse. Nay nay. Whip and nay nay. Alright, I'm back. Alright, let's smash out this decals vid. And then maybe start on the fluid sim vid. Vid. Who says vid? Hey man, love your vids. Actually, I think that's normal. Vids is a normal word to say, right? Alright, let's get cube. Cube. Sorry, let me go to the screen. Cube. Another cube. And another cube. Another one. And you know what? Let's do it in the foliage zone. All right, dank. Very stale. Delicious. I love stale water. Alright. Hello and welcome back to another Prismatica Dev video. Today we're going to be talking about decal masking. Now, what do I mean by decal masking? So if we go into our little session, and let's just create a material called Decal Mask Exemple, as the French would say. Let's go into the material, and we're going to go and set the material domain to be deferred decal, and the blend mode to be translucent. Now, let's grab my face. Yeeto Mosquito. And we're going to chuck this into the opacity. And essentially, we're just going to put my face. I can just drag a decal, pardon me, into this thing. Now, for some reason, my foliage isn't receiving decals. I'm just going to change that. I'm just going to change that for the sake of the video real quick. Receives decals. Effects, blah, blah, blah. Receive decals. There we go. Okay, cool. Okay, so we have a decal. We have a decal, and maybe for some funny reason, we want it to be this big, right? We want it to cover this amount of space. However, I don't want it on this cube. For whatever reason. This cube, I just really don't want this decal on this cube, or this type of decal on this cube. Maybe this is like a character that I don't want to receive, you know, the kind of ground cracking effects and stuff. You know, you don't want it to like show up on their shoes, really sketchy. Because maybe you needed the decal bounds to be big enough to account for the curvature of the landscape. Who frickin' knows? I don't really care. But we want to just exclude it from this thing. Now, that isn't to say that we don't want any decals to be on this cube. So, for example, maybe we want blood splatters to still appear on this cube, or this character, but just not this guy right here. Who would want this guy on their cube? So, how do we go about doing this? Well, in our decal mask example, we can actually access, this is a little known fact, we can actually access some of the scene textures. Where the hell are they? Scene texture. So these are like post-process buffers, usually, but we can actually access some of them in the decals. So if I just plug this in, it should give me an error. And it says, decals can only access scene depth, custom stencil, and world normal. Now, this should give you a little clue onto what the heck we're going to be doing with this node. So the first type of masking we're going to look at is custom depth stencil masking. This is probably the most selective of them. Now, let's grab our scene depth and our custom depth. We could get our custom stencil. There is one just called Stencil Mask Compare, where, I mean, if we just look inside this, it's got some stuff going on. All I want to do is just grab this, and we'll just chuck it out in here, just so we can, like, see what's going on. And there are some other, there are just some other things, right, that we might want to do. Okay. So let's get this and that. We'll put our stencil up here. Custom stencil. Get the R value. It's not RGBA, but, you know, it still needs to be just the R value. And then this part here is our, well, whatever ID we wanted it to be. Oops. So let's just hold 1 and get just a random float. Let's just set this to like stencil value number 3. We'll chuck that into the B. And then let's multiply the alpha of our decal by this value. So this is essentially saying if it is B, if A is equal to B, then return 1. But if A is not equal to B, then return 0. So if it is custom stencil number 3, we do this. Multiply by 1. And if it isn't, multiply by 0. So if we now go back into our scene, you can see nothing is receiving our decal. However, I can grab these two cubes, go to their custom, render custom depth pass, yes. You can see they're still not receiving the thing. But if I go stencil value number 3, then are these receiving decals? What the fuck have I done wrong, huh? Eh? Wait, did I compile this shader? Yeah, what the fuck have I done? Why are you... Oh, right, nothing's going to the base color anymore. What am I doing? Okay. Wait, what the fuck? Bruh. Custom stencil 303. This guy. If 3. What are you doing? What? How have I fucked this up already? You know what? Stop recording. Stop the damn recording. Stencil, mask, compare. Okay, why the frick? Custom depth? None. Custom depth, yes. Why are you not fucking... What the fuck? Eh? What? What are you doing? That one's definitely not right. Oh, is it because of this? Oh my fucking god. I want to die. Right, I still had that set to custom depth stencil 3 from when I was doing an example like 2 hours ago. And so it was drawing it like this. It was revealing it. Oh, such a fucking spaz. Alright, alright. Let's go over that again. Let me just set these back to none of that and do the thing. Okay. So, we're just going to use this stencil mask compare function. If you do want to know what it's doing under the hood, it's pretty much just saying if A is equal to B, then return 1, which is yes. And if not, return 0, which is no, we don't want to show this. So if we go back to here, we just say ID stencil mask number 3, for example. And then we're just going to multiply our opacity by that value. So anywhere that it isn't stencil mask 3, we are going to get a completely see-through decal. Okay, so now if we look, again, none of these have been assigned to the custom depth pass, maybe I just want these two. So let's go render custom depth pass, custom depth pass. And then, you know, stencil value 1, nothing. Number 2, nothing. Number 3, bam. We're getting the decals. So this is saying render the decals only if they are stencil number 3. However, in our initial, you know, what do you call it? In the initial pitch, we were saying we want it on everything, including the foliage. Now, foliage is just especially fucky. We want it on everything except this guy. So in that case, we would actually want to set these guys custom depth to be disabled. And especially if you're dealing with things like, you know, landscape grass types, like the auto landscape grass, where you can't draw it to the custom depth. You want to use an exclusion mask instead. So we could say custom depth stencil number 3, 1 minus the mask, and put that into here. So this will draw it everywhere, including on our foliage and everything that is receiving decals in the first place. But on this one, if we set it to be custom depth stencil 3, it won't receive the decal. So this is how, if you had a character and you had, you know, all of your ground / foliage burning decal effects, we're going to go into, you know, stencil value 3, then you could exclude number 3 from your character material. So your, so you could exclude, you know, channel number 3 from your character mesh by drawing it to the custom depth pass, and then it would be excluded from those particular decals. But you could draw other decals to your character that didn't have this little bit of logic in the decal material. Now, one thing you might notice about doing any kind of masking like this is that it doesn't give a frick about depth. So you can see that this stencil value is just going straight through this guy here. It's excluding the decal being rendered on this mesh where there is, you know, there. And this is because the stencil pass doesn't have depth. It's just drawing, you know, grayscale values that can then be masked out. It does like some bit shifting so they can all technically overlap each other, but whatever. So what we need to do in this case is use the scene depth and the custom depth. So what we want to do is get scene depth. We're going to mask. So what we're going to do, we're going to mask just the first channel of scene depth and of custom depth. And we are going to subtract one from the other and then saturate that. I think we have to subtract some kind of safety threshold from our custom depth. I'm just going to do 5 for this instance. So if we just go and multiply this mask that we've created by the opacity as well, then... Alright, well, if we do that, then I've fucked it up. Let's try it the other way around, where we do scene depth subtracted from custom depth, and that's still fucked up. How about we do it this way, but we 1 minus the result? And maybe that will give us what we desire. Still not correct. Is this supposed to be adding? You know what? I had a fucking... I literally did this. To this one. No. It was called decal masking methods. Okay. You know what? Custom depth -5, subtract this. Okay. Okay, so we... So we're going to be using this little bit of logic here. Let me just check that it actually works first. That's something that we should check. It isn't working. Why is this not working? Is it because we're doing an exclusion? So we actually want to multiply it here. And then fuck with it. Custom depth, scene depth. Custom depth, scene depth. What have I... Why can I not... What the fuck? Let's do U by U and not there. And then... No, that's still fucked. Stop recording. Alright. Is it... Let's just say we only want it on this guy. Yeah, so if we only wanted it on here, then this would work. Where we multiply by this value. And that would say anything in front of it, we don't want to get done. Then we would 1 minus that and do this, and that would be exclusion. Exclusion, inclusion. Okay. Okay. Alright. Okay, so in this little setup here, we are subtracting the scene depth from the custom depth with just a little offset. This is just like a little safety offset so there's no Z-fighting. And then this is just saying, is the custom depth in front of or behind the scene depth? So, for example, we want to exclude this decal, but only in the places that are behind the scene depth, with a little bit of safety so that if the custom depth is the scene depth, we have, 5 units of grace towards the camera. So in this case, we would get this here, and we would, after our stencil mask compare, we would multiply it by that. And then this 1 minus is pretty much just saying, is it an exclusion or is it an inclusion? But if we do this little part here, then it won't care. So if we do that, we hit save, you can see that, yes, we're excluding it from this guy, but we don't get it bleeding through like it was just previously. And if we go and just flip this, so we're not 1 minusing it, then it will only appear on this guy, but it isn't going to appear through the other things. So for example, if I wasn't doing this, then this would bleed through this guy. So there we go. Now, with our stencil masking... method, the best approach is to use exclusion masks rather than inclusion masks, depending on the application. So, for example, if you just wanted to exclude characters from something, it would be better to use exclusion. However, if you wanted to include it only on, one thing, then it would be better to use an inclusion mask. The reason for that is that drawing things to the custom depth pass takes extra performance because it has to do another depth pass and the stencil value and all that kind of stuff. So the less things that you're drawing to custom depth, the better. The less that the custom depth there. The less things the custom depth pass has to actually, you know, do a draw call for, get the location, do the blah, blah, blah. So just keep that in mind. And also keep in mind that it's really hard to access custom depth for some things. So for example, like foliage. I don't know if foliage can draw to custom depth. Even if it can, you wouldn't be able to toggle it at runtime, most likely. Let's see. Custom depth. Okay. Foliage can draw to custom depth. Like that. We can exclude these from it. But that's... Look, that's pretty overkill. That means we're rendering all of our foliage to the custom depth pass. So we're doing 2 depth passes for all of the foliage. So it would be better to just do it the other way around, where you exclude things rather than where you... So in the case that we didn't want it to draw on anything but this cube, it would be much more efficient to just go into the material. It would be much more efficient to go into the material and just use an inclusion mask where only things with ID stencil there. Where only things with stencil ID 3 are going to receive this decal. Now, just to prove that this works, you know, with multiple thingers, let's just duplicate this. Except this one will make, like, red. This will be the evil... Oh, the evil face. And then I'll chuck this into the world, and it's red. But let's give it a different stencil variable. Maybe this one can be an exclusion for things that are stencil mask 2. So this red one, drawing everywhere, including on the one that is including this decal. So this decal here, no matter how big it is only going to get drawn on this guy. But this one is going to draw everywhere except on this guy. Stencil. Oh. Custom depth. Stencil number 2. There we go. So that is stencil masking. One little thing you might notice is a tiny bit of fringing around the edges. Again, that's just something kind of unavoidable because of stencil masks and how they work. And you'll also notice, because we're doing that little 5 units of grace, there is a slight bleed of the exclusion/inclusion masks. If I was in unlit mode, we'd be able to see. So you can see here, there's a tiny bit of bleeding there. You could reduce that value, but the more you reduce it, the more you'll find flickering and some kind of weird artifacting when you're on, like, steep angles. But, yeah, just toy around with it. You'll figure it out. All right. Now, one thing that we could expand upon is you could use stencil mask ranges. So you could, like, get really freaking fancy and say that anything between 3 and 135 exclude this material. Obviously, you'd need to keep track of which things are in which stencil mask, but obviously you can get really, really fucky. The way you would do that is... how the fuck would you do that, huh? You know, I'll take the whole... Let me explode the whole thing. There we go. Alright, let me figure this out first. How do we do a stencil range? So if it's 1, 2, 3, 4, or 5, we just do map range. Oh. Well, no, I could do... I could, like, compress it around. Yeah. So, stencil value. Fuck this. We just saturate. Stencil value divided by... Okay, we have value 1 and value 2. So from 0 to 5, we want this to return 1. So that means 0, well, 5 minus 0. So if this was 1 or 2, then it would be 5. So this is max value, min value. That gives us our range. So we then get our stencil dude divided by the range. Or do we add the min value first, then divide by the range? Or do we divide by the range? Yeah, no, it's this. Then we'd have to seal that. Right? Seal. Yeah. So this should, in theory, anything between 5 and 2 should include this. It is an inclusion, yeah. So, stencil 1? No. Stencil 0? No. Well, fuck me dead. Alright. Stencil 10? Okay, I fucked it up. How the fuck do I... Do I want to subtract the initial value? Oh, sorry, the min value. Then divide it by the difference between them. Zero, 1, 2, 3, 4, 5. Wait, why is that? What is that? Oh, that's receiving this guy. Is it? Yeah. So 0, 1, 2. Right, 2 is the exclusion for this one, isn't it? So then 3, it includes. 4, it includes. 5, it includes. 6, it... Right, because it's the values above it. Okay, Oh, my brain. Before we seal, we subtract 1. Then we absolute. Instead of seal, no, we can just floor the result. Then absolute. Then one more. Oh, well, then saturate, then 1 minus. Bam. Math. Why do I know that that's the right thing to do? I don't know. That's just what my brain said. Okay, so 0, cool. 1, cool. 2, it's in there. 4, it's in there. 5, fuck. 5 isn't in there. But then 6 also isn't in there. So maybe we just do this plus 1. YOLO. So now 5 should be in there. Yes, just so it's inclusive. Okay. Okay, so with this tiny little bit of math here, we can get our max value and our min value. This is inclusive max and min. That's why we've got this little add 1 there. But essentially we calculate the range of our stencil value. So between 5 and 2, the range is 3. Then we subtract the minimum value from the stencil and divide it by the range, and then floor it. So that means everything within our range is now 0, and the things either side of it are, you know, -1, -2, whatever, and above it are just some values above 1, or 1. So then we absolute so that all of those -1 values become +1, but all of our nice 0 values, which are what we want, remain at 0. Then we're just going to saturate and 1 minus it. Obviously, you'd leave the 1 minus out if you wanted it to be an exclusion mask, but this is an inclusion mask, so it's kind of around the wrong way. But, you know, YOLO. And so, again, values 5 and 2. So let's go to this guy here. Set our stencil value to be 0. You know, it's 0, cool. Set it to 1, nothing happens. Set it to 2, we get our decal back in. Then, if we set it to number 3, it's also in there. Number 4, it's in there. Number 5, it's in there. Number 6, it's excluded. So we now have a decal stencil mask range. So anything within that range will now receive this decal. Now you can also see that, you know, this one here, Evil Charles, remember that he gets filtered out on value 2. So if we go to this cube, and we want this cube, and we want this cube to have this guy, but not to have this guy, we could use value 2, because 2 includes good Charles, but excludes evil Charles. But if we wanted it to have both, we could use 3. And so you can have all these, like, real fucked up, overlapping combinations. You might need to grow, like, an extra brain cell or 2 to actually, like, figure all this out, or, like, write them down. This is way above my head, but anyway, you could do ranges such as this if you could organize all of it. Now, the other kind of decal masking that I want to talk about, which is probably more applicable, I don't really know, but we can do... but when you're doing decals, right? Let's say, like, I'm doing this decal and it's like, I want to, like, splat it on a wall. Let's make a wall. Let's make it really thin. Real thin boy. And I've got this decal here. And I want to, like, you know, I want to graffiti my face on this wall. And I want it to look like this. Hell yeah. So I want to graffiti my face on this wall, but you can see it bleeds through to the other side. And that isn't ideal. So what we can do is, let's just look at our decals space by going into, like, object transform mode. You can see that our decal is facing Z. So you can see that our decal projects in the x-axis. So I personally like to think that the decal is actually facing out this way. So just keep in mind that's how I like to do it. So if we go into our decal, and we're also doing all of these, you know, exclusion, custom depth bullshit. So we're just going to keep that over here. We have the original textures alpha going into here. We can do one more masking type, which is world normal masking. So let's grab scene texture world normal. And let's get -x 0, 0. And we're going to transform from local to world space. Then we're going to use a dot product. And we're going to dot world normal against our decal's orientation in world space. And then you can mess around with, like, the offset and hardness of this, but I just can't be fucked. And so basically, if these two angles are the same value, or close to the same value, then it's going to return 1. And if they are at 90 degrees to each other, it will be 0. And if it's the opposite of each other, it'll be -1. So, for the sake of this, we might want to just maybe multiply this guy by, like, 2 before we saturate it. Which is just going to make it so that where the dot product, you know, would normally be 0.5, it's going to be 1 anyway. So now let's just multiply our opacity by this mask. And we should see that everything's good. We still have our face on the wall. However, if we look behind the wall, it's gone. It's disappeared. So our decal is now taking into account the, well, I guess the normals of, you know, what it's doing. You can even see on this guy here, if it's facing away from it. So if it's facing away, it won't draw on this side, but as soon as the sides are, you know, kind of matching, then it's a lot happier. I might even just get rid of that, because I think the dot product... saturate 1 minus. Saturated, alpha. Okay, yeah, that's all good. Cool. So you can see if I've got this right here... Okay, why does it just, like, clip out like that? Is that because of the stencil shit? Transform vector, local space to world space. Oh, shit! Okay, one thing that we'll need to do is normalize this vector before we dot it. Quite important. Because we're not dealing with positions, we're dealing with... There we go. We're dealing with vectors, like directional vectors. So now you can see, as I turn this away from the wall, it will fade out. So if it's at 45 degrees, it will be only like 0.5 opacity. As I get to perpendicular with the wall, it will fade out to 0. these would all be negative values around here, and then we'll start fading it back in over here. And then, as we're dead on with the wall, we have Megamind once again, but nothing on the back. Now, if you wanted to, like, you know, stop it from bleeding on the top of the wall, so stop it from here, but do it on both sides of the wall, you could just grab the absolute of the dot product, but all of the kind of mathy stuff, I'll just leave up to you guys. If you've watched all my previous videos, you should know how to manipulate, you know, directions and math like that. So now you can see we're excluding it from these ones, but we're including it on both sides. Although if I turned it this way, we would get it up here, but not on these guys. So, again, that's just another really handy method for doing decal masking. Again, it's really handy for when you're doing things such as, you know, putting huge effects onto your landscape, but you don't want it to appear on, like, buildings that are, you know, jutting up at, like, you know, right angles, 90 degrees from the landscape. So, there you go. Another handy little method. Keep in mind, this is the pixel normals. So, if we had, you know, some normal map going on here, material, and we go, you know, normal map, dirt, rocky ground, Priz rocky ground. I've got to unpack my normals, just ignore that. We do this, we chuck that onto there. So you'll be able to see that if I rotate this, technically it should be, it's kind of hard to tell, but it should be kind of obeying the pixel normals. Maybe if I really just, like, juice this up to, like, -10 flatness, which is very not flat, by the way. Does it not fucking care? Or is it just that the dot... Maybe it doesn't... Maybe this is pre-pixel normals, right? That's all I can think. World normals. Does this have pixel normal? No? Can I get pixel normal world space and do that? Does that work for the decals? It doesn't. Am I just tripping balls? I could have sworn that it took normals into account. World normal is totally pixel normals, isn't it? I'm dotting you against the pixel normals. So, like, fucking do it. Just do it. Is it because of the absolute? And the multiply by 2? No. So maybe this gets done before pixel normals get figured out. Well, there you go. I thought we could do pixel normal, like, filtering, but it would seem that the decal pass gets done before the pixel normals have been computed. So this must just be the vertex normals. Yeah, I really don't know why that is the case, but I guess it makes sense. So, there you go. We can mask decals using stencils for individual objects that do or don't want particular stencils. You just have to figure out all of the channel stuff yourself. Someone in my chat compared it to collision channels, where you've got, like, this thing interacts with these 4 things, but not these things, but the other one interacts with, like, the thing, these 2 things, and also these two things, but not these things. It's a complete mess. It's up to you to figure it out, get organized. And then we also saw that we can mask decals based on the world normals. So if we want something to be painted on a wall, but we don't want it to show up on the other side, we can use the world vertex normals to do that masking. So hope you learned something new in today's video. If you did, make sure you've liked this video, subscribe to the channel for future videos, and if you do want to support these videos monetarily, you can do so for as little as $1 per month in the Patreon, which is always linked below. So huge, mega shout out, as Epic would say, a mega shout out to all of my mega patrons who, you know, I could not do this without. So thank you very much for watching, and with that, we say goodbye. Goodbye. All right, I'm still streaming, by the way. I'm still streaming. And no, I'm not going. I'm not going. I'm just... my voice is getting kind of sore. No, I'm not going. Stop. Stop. You guys are... What the hell? I'm not going. I'm still here. I'm still here and I'm vibing. And I'm so hungry. I just want nachos so bad. I have so much nacho beans to eat. Like bean mix. Jed, shut your mouth. Shut your damn mouth, son. Don't even. Do not even. I'm not going yet. In some Taco Bell right now? Hell yeah. Leave us. We don't deserve you. Sag. Stop sag baiting. Let's go to Niagara videos. Grid2D video. Cool. Okay. I think what I want to do is just write the fluid sim first, and then do the what's it called? The video after I've kind of figured it all out. I don't really want to fuck with like boundary conditions and shit, but yeah. Been living off nachos lately. I mean, they're just, it's a good healthy meal. Nachos are. Aside from the corn chips and the salt. But the rest of it, super healthy. Let me give you guys my nachos recipe, right? So, and this makes like a bulk, like a pot of nacho beans. 1 tin of either a Mexican bean mix or a 4-bean mix. Always get the bean mix. That's like, what, 90 cents? Fuck yeah, go for it. A can of lentils. That's 90 cents. Bam. Fucking, we're good. We're good. We've spent like $1.80 and we're like halfway there. A can of tin tomatoes. 90 cents. That's, what's that? That's, $2.70. We're at $2.70. That's our budget at the moment. $2.70. Trying to think what else you could put in it to zhuzh it up a bit. It depends. Okay, if you've got like chili oil, like Asian chili oil with like heaps of MSG in it, then get some of that. Put a teaspoon of that in with like some what's it called? Chuck some of that in. Fuck yeah. if you've got capsicum in the fridge, cut some of that shit up, chuck it on a fire or like in a pan, fry the shit out of it, chuck that shit in. Cool. Onion. Do a whole onion. Whole ass onion. That's what, like fucking 20 cents or some shit. Cut that motherfucker up in the pot before you put all the rest of the shit in and put it in with the capsicum. Do that. Let it, you know, fucking caramelize. Not caramelize, but let it sweat. Green chilies. Yeah, green chili is good. You need, like, lots of color. You need some green stuff. I always put in, maybe controversial, like 3 or 4 leaves of kale, and you strip the leaves off, so you get the stems. Cut up the stems. You get like little chunky boys of kale stem. Chuck it in. Let them cook, you know, with the onions and shit. And then later on, you cut up the kale, like you chiffonade it. You like dice up the kale, chuck that in. You know, it's just free iron. It's free greens. You can't even fucking taste it. Kale is like, okay, some people like don't like kale for some reason, but it's literally just like lettuce plus, you know? Kale is like lettuce, but it lasts twice as long in the fridge. Like, I've had kale in the fridge for like 2 weeks, and it just fucking, it's still kale. It's like, it holds form, it's green, it doesn't go all fucking mushy and like gooey and shit like lettuce in a packet does. It's just like, it's just so good. And once you cook kale, like boil it in water, put it in shit, it just turns into spinach. But it's like spinach that doesn't turn into like fucking, you put in like 5 handfuls of spinach into a pot, and it turns into like 1 little marble's worth of spinach once it all, you know, loosens up. So kale is just like spinach plus. And it's like what, a fucking huge bunch of kale's like $2.50 in Australia? That's hella good. That lasts me like a week or 2 weeks. So I highly recommend kale. So I put kale in my bean mix. Coriander, yes. Chuck coriander in if you've got it. You can use shitty dried coriander if you need. I always put, instead of putting cumin in my guac, I do curry powder. Just like English, you know, the English Indian curry powder. That's just like cumin, turmeric, coriander seeds. I don't know what the fuck's in it. I just put like a tablespoon of that in. Just chuck it in with the bean mix. Then what else? Oh, paprika, smoked paprika. Chuck some of that shit in. Black pepper. Chuck that in. Garlic in with the onions and stuff at the start. And then once all of the veggies and the kale stems have been, you know, cooked up a bit, with all the spices, you want to kind of fry the spices off, you know, like Indian style. And then you dump the beans in with all the bean juice, with that thick bean juice. All the, what do we call it at bars and shit? Aquafaba. You chuck all the beans in with the bean juice, because that will just thicken it up, you know? And then, yeah, lentils, beans, tomatoes, smush it all around, let it just fucking do its thing for like 2 hours. Cut up all the kale leaves, like dice them up, chuck them in, stir them around, let them just do their thing, reduce down, and it's just like, it's just good to go. Super easy, costs about like $5 for 1 serving, and it lasts for like 2 weeks. You get so much nachos out of a pot of beans. Or you can make like cheese toasties with, you know, with these beans and shit, like in the press. It's just like, so it's good. And most of the time you don't even need to add salt. Usually instead of salt, I use nutritional yeast, like yeast flakes, which gives it a bit of like a Not like, I mean, it's kind of Parmesan cheesy. But the yeast flakes also, like, thicken it up a little bit, you know? It's like adding flour to a sauce. But instead you're just adding, like, yeasty goodness. Which has heaps of vitamin B12. So make sure you get your yeast. Although it's kind of it's like $8 for a packet, but that lasts like 2 weeks or a month, depending on how much you use it. But yeah, that's my bean mix. It's so fucking good. And it's healthy. So it kind of, because it's healthy, you can just dump it on a bunch of corn chips and shit. And it's like, kind of healthy, you know? Plus, if you don't put salt in the bean mix, then, like, it makes the salt on the corn chips sort of acceptable. Because it's kind of like you're putting that salt in the bean mix, in a way. I don't fucking know. Yeah. I was thinking of doing a cooking video for, like, April Fools. But then, I never did it. 5-minute cooking recipes when? Honestly, I could do that. I used to work as a chef. So I do, like, I cook all my meals. I mean, I can't even get, I can't get takeaway out here. Like, they don't deliver this far. So I have to cook all my own food. Which is good. I love cooking. I actually enjoy cooking. Cooking is like... You know when you're just like... You know when you're in Unreal Engine and you're just like dicking around with some funny shader stuff that isn't even like relevant to what you're doing, but you're just like, oh yeah, this is cool. I wonder what happens if I like fucking absolute 1 minus, subtract 5, seal, multiply by 20, you know? And you're just like fiddling around and shit. That's what cooking is like. Cooking is like... dicking around with shaders. You can just like add shit in and like try dumb stuff or just like get a bunch of, you know, these fucking zucchinis, like this zucchini's going off. It's like, okay, well, the zucchini, it's like, it's going mushy, it's not moldy yet. But it's like, what can I do with this fucking mushy-ass zucchini? Well, I could make, like, smoked zucchini soup or something. Like, cut it up, grill the shit out of it, chuck in some fucking potatoes, boil them all in stock, blitz it, and you've got, like, a delicious, smoky zucchini potato soup. And it's like, you know, it's fun. I think more people should cook. And people that do cook should cook more often. And people that can't cook should learn to cook, you know? I'm a very strong advocate for, like, cooking food. No Control-Z in cooking, though. There is some Control-Zs, like... oh shit, I added too much salt. Therefore, I'm gonna add some lemon and maybe sugar. Or just add more mass to it, you know? Add another can of beans to dilute the salt. Or if something's too sweet, add lemon, you know? Add lemon, add salt, and then you can hide the sweetness. If you burn something, you can, you know, you burn toast, you just scrape off all the burnt bits into the sink with a butter knife. Or if you burn... This happens to me quite often when I'm cooking beans. If your beans burn, like they dry up, usually it forms a layer at the bottom of the pot. So if you don't go in and stir it around, you can just like tip the pot into another pot and all of the burnt bit stays at the bottom. And then you've just got this nice, like, almost intentionally smoky, you know, barbecue-y beans. Same for rice. Yeah, if you burn rice, if you cook rice too long, you just tip it out. Don't get all of the burnt shit at the bottom, and, like, you're good to go. So cooking is quite forgiving. Even like cooking cakes, or even like baking bread. Like, sometimes you cook a cake and it like just fucking collapses in on itself. But like, you can still eat that cake, even though it looks like shit. It doesn't look appetizing. You could like a good life hack is if one of your cakes goes wrong, you can just cook it until it's like cooked, and then break it up into chunks and just make like fucking tiramisu or like trifle or something with it. You know? Or just use little cake bits to like dip in coffee and eat them. Or you could even like break the cake up into chunks, squish them all flat, and then you've got kind of like cake biscuit things to dip in your coffee. Like, there's really not much. Break the chunks, egg and milk covered with chocolate. Fuck. Yeah. There's just so much stuff you can do with cooking to, like, recover. Switch to a rice cooker, never looked back. Amethyst loves using a rice cooker, but I'm like an avid pot rice enthusiast. I have the method. I know I can, like, become a grain of rice, you know? I know just how to do it. To my liking. Which is 1 cup of rice, 1.5 and a bit of water, like cold, heat it up with the lid off. Yeah, I don't wash my rice. I love it nice and fucking starchy. And then let it boil till it starts to bubble. Take it onto like the lowest heat possible and chuck that fucking lid on it. And then it just does its thing. Once all the water dries up, you just turn it off. Keep the lid on, just let it sit. It'll just steam itself. Dry rice because I fry onion, garlic, and the dry rice before adding the water. Yeah, true. Like risotto style. Because in risotto, you cook risotto in the fry pan. Where, yeah, you do the onion and the garlic, and then the dry rice, and then you add stock, and you let it soak up. Then you put in a little bit more stock, and you let it soak up. And then you put in a little more stock, and you do that until it's just banging. Chuck in your mushrooms, enoki mushrooms, your fucking, you know, button mushrooms. Matter what, depends on the type of rice you use. That's true. Everyone talking about rice cookers and shit. Me with my gas stove. I'm the same. I just like... I don't use slow cookers. I don't use rice cookers. I don't use air fryers. It's just fucking gas. It's just fire. Fire and metal, baby. Fire and metal and oven. I'm so fucking hungry. Maybe I should just... Air fry must for cooking pizza. I don't mind oven for pizza. I love wood fire oven. I used to work at a wood fire pizza place. So I got really handy with the paddle. Like the big... the shovel. But yeah, it's The most stressful part about doing wood-fired pizza is putting the pizza. You've got like your just raw dough pizza with all the shit on it, and you've got it on like a little panel, and you got to like fucking. You got to like get it onto the floor of the oven without like stretching it and it fucking like falling apart and shit. It's way too stressful for me. I don't even know, what is an air fryer? Is it just like an oven? Because that's kind of what... Is it just a fast oven? Circulating hot air rather than submerging your food in masses of oil. So yeah, it's just a convection oven, right? But I guess it's small, so it's more efficient. Yeah. And true, all the grease would drain out. Yeah. Small and fast. Just like Jed. Just like Jed. Small and fast. Sorry, that was a low blow. That was... something you can see with the Niagara system? True, true. If it was much higher than a convection. Okay, okay. I mean, yeah, air fryer kind of sounds based, but... So when we look at 40-litre air fryer that can fit an entire chicken. Shit. Well, I mean, small compared to, like, a full oven. I guess that's the other thing, is that with an oven, you've got something on one shelf, but it's heating up air throughout the entire thing, and also dealing with heat loss throughout the entire thing. So, yeah. I mean, yeah, I get it, I get it. Alright, let's just fuck around. I think what I'll do is I won't film the video right now, but I will set up the fluid sim for it. I'm gonna go to this scene. Cool, cool. Yeah, my voice is really tired. Okay, so tutorial system. So we have this stuff. It's drawing the balls. Draw the balls, do the thing, add input to sim. Yeah, whatever. Final color should be velocity, but fuck it. This one here, trail decay. So this is our diffusion value, which I will... Maybe I'll skip that. Let's call this the advection. So we're going to get up, down, left, right. I don't know if you really... Like, is there anything wrong with using the middle value and getting the average? I feel like that should be allowed. So we do this, we convert this to, so this is a 4-fer, we're going to go to a 2D. X, Y to X, Y. We're then going to sample previous grid for vector at unit. XE to unit plus this guy, or is it subtract that guy? You know what? Let's change it to be XY. Draw the balls, add input to sim. This one. Let me just do a duplicate module. Let's chill that out. scratch pad. This is called advect velocity. We're gonna get grid. Epic gridge moment royale. Grid. We're going to get previous vector 2D value. We're going to get x plus. This is called wind velocity. Oh, we'll call it fluid velocity. Why not? Gonna get x negative, y original, y original. Grab these ones, y plus, y minus, x original, x original. Grid, I will schmack that from here. Get it on the flow. Schmack that. Alright, add all these bad boys together. So we get the average surrounding velocity. Divide that by 4. However many surrounding cells there are. So then this is the amount that we want to advect the fluid by. So, we need to know, well, in this case, our fluid is 1 centimeter per cell, so I don't have to fuck with anything other than delta time. So we get this value multiplied by delta time. We get the execution to unit. We add or subtract this fella from this fella. And then we sample previous 2D value using this. So we're just distorting the UVs. Fluid velocity, bam. And then that is now the new fluid velocity. Stat context. Bam, bam. Schwow, schwow. When we add input to sim, we actually just want to do, instead of final color, let's add 2D, vector 2D, fluid velocity, stat context, parameters, well, fluid velocity plus the input shit. We just want to convert our ball's input multiplied by delta time to a 2D vector. XY. Add that to the current fluid velocity field. And then make new fluid velocity. Cool. And then in here, let's just get fluid velocity. 2D, sample previous vector 2D value. Oh, sorry, get previous. Get 2D at index XY. Fluid velocity. And that will just, yeah, convert. That's fine, whatever. So this should still draw something. Nope. Why is it not drawing anything? Oh, right, because I'm not. Grid. Right, there's grid. That has that. That's drawing fluid velocity. Cool. Alright, it is doing a thing. I think it's dissipating too quickly. Why is it not... So advecting's doing that. Okay. How can I just make it stick around a bit longer? Well, I can just draw more of the balls. Balls draw more shit to the thing. I mean, yeah, I can see it doing its stuff, but it's a bit fucky. Right, it's because in here we're only drawing small values to our render target. So these are going like big, but then going small. So we actually just want to go... you know what, I'll just... Yeah. Have you ever tried coding in general? Yes, I do a lot of programming for this project. But currently I'm just doing silly things and doing tutorial videos. Cool, cool. Well, there we go. There's fluid advection. To some degree. Bit spooky. Yeah, we probably don't need to draw that much of it. Right, and then we need to... Can that just not... Can you fuck off? Just... Yeah, cool. That can die. Yeah. You can die. Okay, whatever. Save it. Yes. Alright, then in here... So here we have... We're drawing the velocity, and then we advect the velocity. Sweet. So then... So this is like step 1 of Fluid Sim, which is just advecting values. You know, if I move it this way, then this guy moves that way, and whatever. Why does it go, like, negative? It doesn't matter. So then, with that basic advection shit, we need to calculate divergence, which we can do... we can't do it here. We'd have to do it in a separate stage. I'll just fucking do it here. Pardon me. So this would be another scratchy boy. This is going to be called Divergence Calc. This is pretty much the same as this setup. I misspelled that. It says Dicurgence. So, blah, 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 blah. That can die, that can die, that can die. These are all the same-ish. The grid. We do want the velocity. Now that we've advected the velocity, we need to just correct it so that it doesn't lose mass. Which means we get break this guy, break this guy, break this guy, break this guy. And basically, if x is moved, so it's x minus x, y minus y. Pretty sure. And then add them together. That gives us a scalar value. Now, this gets a bit fucky, so it's... Let me just look at my thing. What's all this vibe coding meme shit? Is this a new term for being lazy? Yeah, pretty much. It's just, from my understanding, it's when you do coding, but you ask ChatGPT everything and just copy-paste stuff in. where, I don't know, where vibe coding comes in specifically. Like, you know, is it because you're just vibing, or because you're getting, like, the vibe of the code? I don't really fucking know. Right, divergence is x minus blah, 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 all added together, divided by cell size. Okay, that's very simple. So that's just, well, it's just divided by 2 in our case. Whatever. Let's call it fluid divergence. Chat coding when? Where you copy paste code from chat? That's literally me whenever I have to do any C++. Divergence calculation. Let's add a new stage. Simulation stage. Just called whatever the fuck I want it to be. Cool. This is going to be called pressure iterate. Iteration source. Data interface. This guy. Grid2D collection. Add a new scratchy boy. Now this one, pretty much the same. Again. Whoop. We get up, down, left, right. But we do we get float values instead. So get previous float value from these guys. So you go there, you die. These guys all die. Pressure. This is called fluid pressure. Oh my god. Visual Studio. God, speak of fucking C++ and it appears. Get out of here. Get out. Naughty dog. You sick puppy. Get out. Alright, fluid pressure. This one. That one. Last one. Schwow. 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 Cool, cool. What is it to, like, shift WASD? Sick. Grid. Epic grid moment. Royale. Alright, pressure. Let me look at my pressure dude. Now this one gets a little bit fucky. I don't care about that. It's just divergence divided by delta time. This is 1 in our case because, you know, area of 1. So it's just divergence in the center, do the thing, blah, 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 subtract, easy. So we're gonna grab fluid divergence. God, I'm fucking speed running this fluid simulation. You guys watch, it'll work first go. Just kidding. We have an over-relaxation multiplier. 1.9, fuck it, keep it cheap. Then we divide by delta time. Weird, I know. Then we add all these dudes together. Shoop. And yeah, just subtract. Is it subtract? Yeah, divergence from the pressure. Divide that by the number of neighboring cells. In this case, it is 4. And that is our new fluid pressure. Change namespace, stack context. Cool. Right. Last stage, that needs our grid. Epic grid moment. We iterate this 8 times. Fuck it, why not? 8's a nice number. Then we need to do another simulation stage, which is just our, what do they call it? projection. Projections. Those projections. You're going to go up there. Then we're going to do another scratchy boy. And then to project, we just get our fluid. Where's our pressure sim? Come back, you fuck. Where's this guy? Let's just grab this guy. Easy peasy. We're just going to create a pressure field thing. So this would be X minus X. Y minus Y. These make a 2D vector. Which then gets multiplied by our thing. That would just be divided by 6, which is all good. Delta time multiplied by that minus divided by 6, but in this case we divide by 4. Divided by delta time, fluid divergence, subtract from that. Yeah, cool. Okay, and then in here, I would just do a gradient, which is, yeah, top minus bottom. Cool. That gets divided by cell size thingoed, and then, well, the delta time's already factored in, funnily enough. Oh, I just realized I'm doing this twice. Yeah, that doesn't even need to be there. It should just be straight in. But anyway, it's literally just this divided by 2. And then we just get our velocity. 2D vector, why not? Vector 2D, fluid velocity. And we literally just subtract this guy from that. That's our new fluid velocity. Stat context. Schwow, schwow. Alright, make sure that's set. Grid. This is just fluid velocity. Sweet. And then in this stage, we get fluid velocity, draw it to the thing. So, what do we end up with here? It might work. It might also just be an absolute nightmare. We get nothing. Cool, cool, cool. That's fantastic. So what's going wrong here is what I want to know. Did I just forget to add... Right, divergence isn't calculating, so that's grid 2D. Also the, advecting velocity. Right. The divergence needs to use previous fluid velocity, which means to advect the velocity. So that would need to be in its own stage before pressure. Fuck my life. Alright, new stage. Last fucking stage. Scratch. No, generic stage. This is called the advect. Stage. Strategy. Advect strategy. That happens before divergence calculation. We just chuck this bad boy in there. Fuck yeah. Execute. Iteration source. Data interface. Data interface. Grid 2D. Advect. Do your thing. That should all work now. And it just shit itself. That's great. Now, is that because I'm dumb? Or is it because I'm stupid? You know? When I do the projection, I'm pretty sure I need to multiply it by delta. Because we divided it by delta on the way in. It could also just be boundary conditions fricking us. It looks like it bounces. So yeah, this is now... See, that only took, what, like fucking 10 minutes? Fucking gaming. Yeah, we'd probably want to make it wrap. Wrapping is kind of the easiest. Because obviously, when something goes here, it then, if it looks over this way, it gets it from over here, but down a row. But then if it's from here, it gets it from up fucking here or some shit. So it's better to just wrap X, Y. Instead of fucking with boundary conditions and shit. So much easier with Niagara emitters were just closure nodes like in material editor. We could just feed node trees into input socket rather than nesting values in the panel UI. Yeah, it's yeah, the way I think of it is like each of these modules. If you just tilted this whole thing on its side, it would be like material function into a material function into a material function. And, you know, you can, like, spaghetti some values from this one down into here, and it's totally fine. But, yeah. I just need to do... Oh, fuck. I should have done this first. Modulo. Fast. This guy. Mod. Cell. No, fuck you. Cell. Num cells X into the X. And then mod plus X. Oh, I wonder if this mod does negative numbers. You know, I never actually checked. Fuck it, I'll just... We YOLO. Do it properly. You go into the X there. Cool, cool. Down here, we do the same thing. When we plus, we mod the cells Y. Bam. Down here, we add cells Y. And then... hold on. We add cells Y, subtract 1, then modulo by this guy. Let me just check I didn't fuck that up down here. We... Ah, I see. No. Yeah, no, we add this after we get that -1. We add this. The fuck have I done? Mod by the max number of cells. Yeah, duh. Add the Y cells to the current cell, then subtract 1, then mod by the max cells. Easy. Let me just fucking YOLO this into... Nice. No, that's fucked up. That's fucked up. Alright, I'm gonna unfuck this by doing this. And then I'm just gonna... Whoop. Hoopla! Just gonna smack these in. Like that. Cool. So that was our, what, fucking advection stage. Divergence calculation. Bleh. Well, firstly. Then we... And then you just... Gridge. Wait, why did... Oh, yeah, because whatever. Alright, they call me the fastest spaghetti in the West. Look at me fucking wrangle. They call me the Wrangler. Of spaghetti and balls. Alright, apply that. Back to here. Pressure iteration. Wait, that's not pressure iteration. Oh wait, that is? Pressure iteration. Wait, did I not do it in the advection? Ah, yes, yes. Well, actually I can keep the fucking grid there. That's fine. Just get rid of these guys. Bam. Schwow. Swing it. Swing it. Ding it. Let's do that. Bam, bam, bam. If you're wondering what I'm doing, then stop wondering. That can die. Fluid velocity. Cool, 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 cool. You've moduloed all that shit. Why did I not just write a function to do this? Wouldn't that be so easy? And then the projection is our last thing. Kill this. Do that. Smack that here. 1, 2, 3, 4. Spaghetti at supersonic speed. Elevator music. It's not hip hop, it's pop. Fuse it. Alright. That should be all good. So, we should now have a stable fluid. Stable fluid. Yo, it's rapping. It's rapping. Get it? As in, like, you know what I mean? Like Eminem. There we go. Wow, look, we made a fluid sim in like 20 minutes. How does he do it? Now you guys just need to copy it, you know? Oh! Oh, it diverged. How did that happen? Did I fuck something up? Projection. Index -1 plus that. Index +1 mod that. And then down here, index +1 mod that. And then down here, index, well, plus that, minus that, mod that. Okay, so it is all fine. I think the problem is... I don't fucking know. Let's also just, like, fade this shit out over time. I could fade it at the end. I could do it at the advection stage, just like chill it out a tiny bit. Yeah. Fluid velocity. Get. Delta. Get delta good drone 1 minus. And then, well, delta time multiplied by some dude. By some small dude. 1 minus. Multiply this dude by that dude. And then the schmoobly dude and the goobly boob. And then we schmee-doob, and it's just doob schmoob, you know? It's just vibe coding. Looks sensual. Yeah, I wonder why it was diverging. Because there's no upper limit to the... Oh, it's because I'm fucking thinging. I'm drawing more balls to the balls, right? Add input to sim. Delta time. Oh no, so that is fine. Why is it that when I add it, it... Is there something in draw balls that I was... No. So it is masked by the ball velocity. Strength is 1. Yeah, when I add input to sim, we multiply it by delta time before we add that to the fluid velocity. Chuck that in. So why does it... Yeah, it's if that goes too fast. Oh, you know what it might be? It might be that the... If the fluid goes too fast, it might be accessing from out of bounds. Might be trying to advect from out of bounds or something. Like this, because now it's like going too fast, and when it goes too fast, it will... Like the modulo won't reach back far enough. If that makes sense. Doesn't really make sense, who knows. Yeah, I wonder why it's just going... Oh, wait, you know what it might be? It could just be that I am stupid. Delta time. No, then 1 minus it, and then fluid velocity multiplied by this value. So that should make it calm down over time. That should dissipate the values. So that might help with the fuckiness. Oh, no, it was a corner access. What the fuck? Okay, well, I've definitely fucked up something. Is it this corner? No, other corner. No, this... Well... This one. Yeah, what? I've fucked something up with the whole modulo thing. Unless one of them I just didn't add it to. Advect velocity. You've got all your dudes doing your dude things. This is plugged into all of them. The order of this shouldn't matter. And again, the order of this shouldn't matter. It should be get the current y index minus 1 and then add, well, add the number of cells, then mod. Yeah, so that's all fine. It could be that one of these nodes is angry or not working. Pressure iteration is, again, we'll get this guy minus 1, add the thing, modulo. That's all good. Everything's plugged in. Divergence is all good. Projection, again, same fucking thing. Get the y index minus 1, add this guy, mod by the thing. They're all plugged in. All the grids are plugged in. Cool, cool, cool. How much money all the render targets take up for all the prismatic plugin effects that you were showing? For all of the render targets, probably about 10 megabytes. Most of the simulate, like the wind simulation is 128 by 128. The ball, or like, you know, the kind of radius, character radius stuff is like, again, 128 by 128. Which is... What's 128 by 128? Well, okay. A 512 by 512 16-bit is 2 megabytes. Which is, like, pretty extreme. But then maybe, like, double or triple that because the grid calculations have, like, multiple variables per, you know, per render target thing. Yeah, I don't know why this is exploding. Maybe I'll figure that out in the thingo. It shouldn't be unstable, but yeah, whatever. Oh, you know what we could do? Which is kind of a hack, but we could just get grid fluid index or unit. Index to unit, XY, sine. Oh, fuck you. Well, I can just multiply by 180 sine. No, fuck you. Well, no. Sine. Sine D. There we go. Sine D's nuts. Multiply that by some number. I don't know, fucking 10, 5. Clamp it. 0 to 1. Break 2D. Multiply these over one another. Fluid velocity. Multiplied by this. And that will just zero it out, the corners, yeah. So it won't wrap. It'll bounce, but it, you know. That should technically get rid of the fuckiness. Alright, so if we just go to the balls, tell them to draw smaller balls, and we get 1,000,000 balls, then we can have fun. Dank. Look at all our balls. You know if it's a bunch of ideas for any part of the world affected? No, so the prismatoscape stuff follows the player around. So yeah, it kind of just deletes things off the edges. Right, and then the last thing we might want to do in this thing is probably at the projection stage, we can just do another scratch fella called advect die. Advet. Advet die. I'll just grab all this shit. Whatever. Advect die. Gridge. Cool, cool. Cells. Grid. Sweet. We get our final... Well, we want to get the... Oh no, this is way fucking simpler. What am I even doing? We just want to get execution to unit. We want to get the new wind... Oh, sorry, fluid velocity to the vector fluid velocity. And we literally want to... So that's velocity per dude. So when I'm doing this, I'm dividing it or multiplying it by delta time. I think I'm supposed to divide it by the size, although our size is 1. But I feel like it's supposed to be the size squared, or it's multiplied by 2. Maybe that's why it was going fucky. Because we were advecting further than the velocity should allow. No, that's our 3D one. Give me this guy. Maybe that was it. I don't know. Whatever. Oh, wait. Divide by 2. Anyway, what I wanted to do was... in here, advect die. Die Ds. We get the velocity. And we... Yeah, no. No. That should be fucking... Hold on. In... advect velocity. We need to divide this by the fucking size of the simulation. Because that's in units. Right? That's more like it, I think. It looks less good. But yeah, I was wondering why all of our velocity values went down so fast. And that was just because pressure was taking over. Should that be double that, though? Or should it be half that? God, I can't fucking remember any of this shit. Yeah, because now it's actually moving fluid around at the proper thing, right? Or is that only using pressure? You know what? Fuck it. We'll just do this. Oh, no, because the... Oh, this is the initial advection, right? So initial advection is the fluid velocity. You know, the average fluid velocity. And then multiplied by delta time. How far back do we want to backtrack? So, you know, that should be the velocity. Because if it's moving at 100 units per second, we'd want it to only backtrack, like... Oh, yeah, 1... Yeah, no, this is right. I mean, it looks less cool because we're actually advecting the velocity now, but then how do we get all our swirly whirlies back? Well, that would be vorticity confinement. Because yeah, if it was just this, then yeah, okay, yeah. You can see it like spazzing. Because it's trying to move stuff way faster than the balls are going. Which is why we get that kind of skipping going on in here. And then it's just pressure. The pressure solver trying to do it from there on. So yeah, this looks cooler, but it's completely inaccurate. It needs to be this. And then, in here, blah, blah, blah. So advect die. Advect die these nuts. Fluid velocity divided by whatever the fucking size is. Multiplied by delta. Delta Goodrum. Then unit, subtract this guy. And then sample. Previous vector 4 value. At this unit. This is called final color. Finale colore. And this becomes final color. Stackety context. Bam bam. And then let's just do a little fucky, you know, in the draw the balls stage. Scratch pad. Let's just get time. Engine time. We will chuck that into a sign, and another sign, and another sign. Why not? So this will be our scale sign. And then we just do these in, I don't know, 2.5 something, 2 point something other than that one. And then this one can be 5 point something. We're going to make a 2D vector. Schmack that, schmack that. Multiply it by this one. For the scale of it. So now we have a kind of randomized 2D offset. We're going to multiply this by 0.5. Oh, then we're going to get the grid 2D. We're going to get execution to unit. And we're just going to say distance. Now, fucking this guy. Well, this guy add 0.5. I can't fucking remember. No, it would be minus 0.5. Then we're going to subtract u from u. We are going to get the length. We're going to divide it by some fucking value. Who knows? Divide by 5. We're going to saturate that. We're going to chuck that into here. Let's just call this ink dropper. Or, oh, no, this is ink dropper. Or dye. Well, no, this would be final color, right? Vector 4. Final color. Plus. Whatever the fuck this is. This, I don't know, lerp. Or just mask a... let's see. How can I choose a random color? We'll just get time. More signs. Sign. Sign, sign for each thinger. Period 0, 1.2, 1.27, 1.34, make vector 4. 1, 2, 3. Well, these all have to be positives. Add 1. Oh, fuck. How can I... Oh, no, I can do this, then add 1. Divide by 2. So this will just give us a random smoothed color. Multiplied by the mask. Add that to the final color here. Smack that. Get on the floor. And then final color is final color. Render target, Grid2D, Grid2D collection. And then we add vect the die, which is final color. We add vect that. That should do a thing. And then if we were saying, draw a render target, and we said final color instead of that other one. Pardon me. We should get... Okay, why is it not swinging? Oh, you know what? It could be... Add input to sim. Final color gets set to 0, which I don't want. Draw the balls. Final color's fine. Okay, let's see. Igorian. Let's get into VFX for games. Into something like stylized spells like League of Legends. Where the fudge do I start? I think my channel might actually be a good starting point. Yeah, I'd just start with YouTube. Just look up, you know, materials, all that kind of stuff. Random location. Alright, this isn't going to be. Oh, what the fuck is this? Rename pin. Final color. Stack context. Okay, so this should just create a random... Son of a bitch. Final color is final color. This is no longer referencing final color. Doesn't need to get it from here. Okay, but why are you angry now? Right, because final color was red before being set in here. So then in here we want final color to be final color. If it hasn't been set, custom is 0. Son of a bitch. Stack context? Fail. Just value and then final color. Not custom, just go to value. What am I doing? I'm just creating a quick fluid sim example. Because I'll be making a video about it next time I stream. So I just wanted to make sure I know what the frick is going on. Finally, it was red before being set. Wait, is that just because... Add input to sim, add vect die. Well, no, that's fluid velocity, not thingo. Also, this needs... and... velocity. But why is this not happy? Draw the balls. That doesn't even use final color. So that's fine. Add input to sim. Doesn't reference final color. In here, we do use final color. And then set final color. But I'm literally saying use value. Bitch, show me. God, these fucking ghost variables. Add vector velocity. You're not using anything. You're just doing fluid velocity. Fluid velocity. Set fluid velocity. Divergence shouldn't fucking do it. Add vector dye is referencing final color here, but that's... Putting this into a Niagara is a bit shit. Yeah, it's a bit fucked up. It might even just be in the overview in Grid 2D final color. I can't even get it here. Can I just see what the fuck is referencing you? Turn it off. Everything's fine. Turn it on. Variable emitter tutorial grid 2D collection final color was red before being set. Okay, but I literally set it so that it doesn't happen anymore. You little shitlord. Let me just change this to stack context. You still gonna fucking piss me off? Son of a bitch. It's because it was an input. Oh, God, I want to die. That's dumb, but whatever. Okay, so now we are just getting fucky. This guy here, I need to multiply it by delta. Oh, and rather than... We want to actually use this as a lerp between the original color and then the new color. We don't even want to multiply it. So wait, this is for the location. This is for like the radius, right? Right, it's a radius in dick space. Right, so this will just draw colors, and then here we should be able to move those colors around using our fluid shit. Whoa, crazy. Crazy. I just don't know why they're not moving that much. Like, what have I dicked up? I probably also want to do like a dropper. We'll just get time into a 2 into a whatever. Just feed them into each other, saturate that shit, and fucking multiply up here. Multiply the alpha by that. Oh, bitch, what the hell? Time, sine. Saturate. Multiply the mask into the lerp final color. Oh, that's delta time, silly. Oh, where the fuck was I? Is that the... Okay, that's the... There we go. Alright. There we go. So now we're just drawing little strokes of shit everywhere. Probably make that sharper. .75 multiplied by 4. Cool. Math. Cool. Yeah, so I don't know if the advection is actually supposed to be divided by this number. Maybe it's divided by half of it. I can't actually remember. I'd figure it out if I had a brain. But I just cannot be fucked. I mean, that looks better. I can just chuck that straight on there, can't I? No, I just need to make sure that that has no collision. Yeah, it's a bit fucky, but... It's definitely not, I'm definitely fucking something up, pretty much. I don't know if this is supposed to be... No, but it would have to be, because the unit is 0 to 1, but the velocities we're dealing with are like in the 10s or the 100s. So, like, it must be that it's just too thingo-y, right? Because, like, if I do it like this, then, like, yeah, it looks super cool and shit, but, like, it's just moving too fast, you know? Like, this thing is moving at, like, 10 units, but it's pushing out liquid way too fucking fast. So yeah, we get like cool trailing and curling and shit, but only because the velocity's moving way too fucking fast for its own good, and then our pressure iterations have to keep up with it, you know? Also, this looks fucking gross. Look at these gross ass... So yeah, no, it's definitely wrong. Yeah, that should be divided by the size. Surely, surely. Which means that... Yeah, I don't know, I guess the rest of it is... technically fine. I guess that's where vorticity confinement would come back into it, you know? We're like, yeah, like, this is accurate. Sort of. Maybe if I just drew... because it's drawing the velocity per second. like distance per second in the draw the balls section. If I just made the balls way stronger, so like add the input to the sim times, not even fucking, you know, don't even factor delta in there. Well, then we'd just get really high velocity values, but all the rest of our stuff would be correct. But yeah, our velocity values are way too big, so it just looks the same. Yeah, that's the main problem, is that, yeah, when they're moving slow, they're just pushing out velocity that doesn't belong to them. Whereas when they move fast, the advection kind of has like a limit, you know? So maybe delta time times some fucking dumb value. I mean, look, it's fucking not perfect, but it's a bit less boring. Just an input velocity multiplier. We'll have some stable fluids. Any fluid enjoyers in the chat? Oh, I could not receive my balls. Yeah, cool. And then I guess vorticity confinement as an extra step, which I could do right now, but I can't be fucked. But I think that's the gist of it. So it shouldn't actually take that long, like the video, to film it. Slurp up that fluid, hell yeah. Want to publish this stuff as is, like sandbox style? Effort. Just effort, really. I mean, I'm happy to, like... there's too many dependencies in this. I'm happy to just, like, give out code, honestly. Well, I mean, that's kind of what the tutorials are, you know? It's me giving out code, but also giving out understanding of the code, which is arguably more important. So many things don't work when I build the game? Yeah, exactly. Exactly. It's just a lot of effort to make sure that it's, like, running well, and there aren't any, like, crashes or anything. I mean, for, like, a toy like this, it's not too important, but, you know. Yeah. Yeah, it's weird. Yeah, there you go. Well, I mean, if any of you guys want to know how fluid sims work, you can just follow this video, and you've got it in the bag. I mean, the thing with a 2D fluid sim, because it can't go up into the third dimension, you just end up with the little, you know, vortices just from the pressure projection. You know? Like, you end up with these little swirly dudes. Whereas, like, in a 3D one, because you've got an extra dimension of freedom, it just tends to look really boring as fuck. Like, if I go to this guy. Well, yeah, this is with vorticity confinement. This bit here. So we're doing a vortex, it's like pushing off the edges and shit, doing cool stuff, whatever. Whatever, good for you. I think this was back up too. Yeah. Oh, fuck, pardon me. So this just has like a little schwinger going around, doing schwinger things. We got the pew-pew, which just... Okay, that's like a directional blast. We have the Kamehameha battle. I guess if we just get the vortex and like set the strength to be 1. Yeah. Angle 0.9, I guess. Inwards. So like with a vortex like this, right? If we don't have vorticity confinement, it just like, it doesn't look like a fluid sim. You don't get that fluid sim pizzazz. Even if I go up to like 10 or some shit. It just looks so smooth. And it's like, what is this even? What am I even looking at? Like, it's not fun. It's just dumb. Same with like, again, if I just get that, the peel, right? That just looks like super boring. It's like so smoothed out. It's just stupid. But then as soon as I put vorticity confinement back in there, it's like, yeah, we get all this like juice. We got all the little mushroom heads going on, you know? So this restores the natural turbulence back into the simulation by letting it, you know, create vortices. Which again, like in a 2D simulation, it can't escape up into the... Like, the pressure simulation can't escape into the 3rd dimension. So yeah, you kind of have to do some kind... I mean, you could just set the pressure iteration to iterate like 128 times, but that's like fucked up. That's way too much. I mean, that would just tank your computer, right? Yeah, to do things like, I have this shear test, where I just have wind going this way and some wind going the other way. And you just see that, yeah, we get like these nice little currents, little turbulencies right here. Go like really hard, like this. Whereas if I did this without vorticity confinement, it's just like giga boring. I've even like introduced some noise with like a texture, but you can see here, like, yeah, it just creates a pressure difference, and it's like super fucking boring looking. So I think in 2D, vorticity confinement isn't really needed, but in 3D, especially because in 3D you're working usually at like a way lower resolution. You know, 128 by 128 by 64. I mean, usually this would be like fucking 16 if you weren't a psycho. But yeah, it just like gets more of the stuff. Thinking about dimensions breaking because of pressure is kind of blowing my mind. I mean, yeah, kinda. It do be like that. But yeah, the thing about vorticity confinement is that it creates little nucleation points, and then it just, like, you know, then those expand upon other, like, creates turbulence, which creates more turbulence, which creates more turbulence. And it just ends up being way more, well, turbulent. Put up to 5,000? Whoa, sheesh. Sheesh. It hasn't exploded yet. That's surprising. Stable chaos. Exactly. I can turn the vorticity confinement up to, like... Well, then it just becomes noise. I think this can go to, like, 20 without shitting itself. Although you also, if you're using vorticity confinement, you have to do, like, a separate diffusion stage. So use, like, the debug fountain. Well, okay, let me just fucking... Let's do the vortex again. So yeah, vorticity confinement 0. Giga boring. Then at 1. Still boring. 5. Less boring. But very stable. Trying to hypnotize you, true. Up to 15, you know, heaps of nice noise. But then past a certain point, it's like too noisy, and you start to get these, yeah, little crystals forming. Little vortex crystals. But then, yeah, you gotta diffuse it by some amount. But yeah, it's weird because I figured out these little kind of crystals that form is actually something that happens in real life. Convection vortex crystals. Where is it? Dynamics of the vortices rotating Rayleigh-Bernard convection? Or stable vortex crystals? Here you go, active vortex crystal. So these little groups, they're like clusters of 4 pixels in our simulation. What's actually going on is this. Where it's like, you know, a bunch of like convection vortices from chaos, but then eventually they become like stable cells. Like this. And they just stay like that forever, essentially. So that's kind of what the vorticity confinement, when it's too high, those little quads of pixels, or I guess they're like little octs of pixels, because it's 3-dimensional. They try to vortex away from each other, but then the pressure simulation keeps them from diverging, but then the vorticity confinement gives them enough extra, like, spin to just remain as little stable doodads. So, yeah. Definitely got to keep it balanced. Just turn them all on at once. Maybe not that one. Just... Dank. So yeah, maybe I'll do a video about this. About 3D shit. I mean, it's not as, like... It's not as useful to know 3D fluid sim. But, yeah. Maybe that can be the homework for the video. What can this be used for, if you don't mind me asking? Ah, that's a great question. I'm going to be using it. I'm going to be using the 3D fluid sim to simulate the weather in my game. So, like, the whole world, like, each cell represents, like, an 100 by 100 meter, you know, area of the world. But then all of the weather and shit. Oh, my audio just crapped out. Hold on. There we go. What plugin? What plugin you mean? Yeah, so in my game, the whole weather and climate system of the world will be simulated using a 3D fluid sim. So all the wind, and the wind carries humidity, and then when the temperature of that air drops, the you know, moisture gets squeezed out of it, it turns into rain, rain hits the ground, and then, you know, the water runs off the ground and settles and, you know, moistens and shit, and then it evaporates, and the temperature gradients create, you know, buoyancy differences, which clouds and all that dumb shit. Snow, cold mountains, rain shadows, all that kind of stuff. The main reason being that the world in my game is like a big flat Earth. It's like a disc with the sun in the center that like goes up and down through like a big hole. That's how the day-night cycle works. And then the you know, the disc kind of goes up and down but slower. Like this. That's really hard to do. So that's how you get seasons, because the days get shorter. But the idea, I'm building it as a plugin so that other people can use it for their procedural worlds or their, you know, authored worlds. But it's like a fully interactive system. So let's say there's like a volcano that explodes. That would heat up that area, you know, because of the lava. But it would also create like an ash cloud, and that ash cloud would get carried by the wind, and then the ash cloud would block out the sun, so the ground wouldn't heat up, and it would get cold as fuck. And so you could have like a volcanic winter just like happen, and it would actually play out as though it would have actually happened. So like if the ash cloud is below the peaks of the mountains, then the tops of the mountains are like, they're not ashy and whatever. And yeah, like you end up getting, you know, when clouds, say there's like a mountain here, and you've got clouds, and they're in like, you know, hot air. Because obviously hot air, I mean, not obviously, but hot air can hold more moisture than cold air. So if you think of it like a, you know, the maximum humidity is like a bucket, and you've got like some amount of water in it. But as that water gets colder, the bucket shrinks, but the water stays the same. So you end up squeezing the water out of the bucket, and that's how rain happens. So usually in real life, when clouds get to a mountain, they kind of deflect up the mountain, But as they rise, because of the air pressure is lower up the top, then as it expands, it gets cooler, which means it holds less moisture, which means that it starts raining. And then usually when a cloud starts raining, it's like a kind of like a domino effect where, you know, little droplets that fall gather more moisture as they fall. And so then the cloud kind of breaks over the mountain. And that's why in, you know, most places, if there's like a, you know, a general wind pattern, usually one side of the mountain is really lush and green, where it gets lots of rain, and the other one is usually quite dry. So all of that stuff just happens automatically. The you know, the system just sorts it all out. You end up with, like, if there's an ocean and a landmass, in the morning, the wind will blow in from the ocean because the land heats up. The ocean stays, you know, whatever temperature it's at, because land heats up faster from direct radiation than the water. So now it's like the air over here is hotter and it's cooler over here. So this air rises and it sucks all this. So you get like a sea breeze in the morning, and then it goes the opposite at night and all that kind of shit. Like, it's just... it's pretty fucked up. It's very overly complex, but it's fun. And that's what my whole, you know, game dev existence is about. It's about having fun, discovering new, complete bullshit, and then open sourcing it and letting people learn from my mistakes, you know? People can look at it and be like, oh my god, this guy made like a fucking simulated global weather system. That's dumb as fuck. I'm gonna not do that. Someone tried it. You know, it works or it doesn't work. It's worth it or it isn't worth it. You know, I'm either gonna not do that because it's a dumb idea, or I'm just gonna use his work as a basis for my game or whatever. So that's, you know, I'm just like exploring all of those really bad thoughts that you have. That's like, what if we like simulated every atom in a game? Or like, what if we made it so you could like cut someone's arm off and then grab their arm and then hit them with their own arm? And like, would the arm do more damage if you'd frozen it first? If you put the arm in a freezer and it would freeze all the blood in it, and then you've got this frozen arm, and you, like, start smacking someone with it. Like, that's the kind of questions that we're doing. It's called Noita. Noita's a very good example of, like, something that... a lot of the stuff in Noita doesn't actually, like, affect the gameplay that much. But it definitely, like... you know, Noita is what it is because of all of the... every pixel is simulated aspect. Otherwise, it would just be any other, you know, any other roguelite shooter platformer thing. But because all of the pixels have a physical property, and you can, like, blow up terrain, and the water flows, and the electricity flows through the water, or through the metals, and the fire spreads, you know, it just becomes a really cool... it's just cool, you know? It's not useful most of the time, but it's just like... it's just cool as hell. And I think especially in AAA, they don't care if something's, like, cool or interesting. They just stick to, you know, same shit. And they only, you know, they only budget for things that will directly serve the game or the monetization of the game most of the time. But I'm just thinking, like, what's something that someone might just notice it for like 5 minutes and be like, oh my god, that's like so cool. And then you know, only interact with it for 5 minutes. But maybe in the future, this is, I'm going on like a mad rant. It's like nearly 5 a.m. But I believe that a game's worth isn't measured by the number of hours played. It's measured by the number of hours after you've stopped playing it that you continue thinking about it, you know? Like, I always think of, you know, this one time in Kenshi, or like, oh, that one time in RimWorld where, like, you know, this thing exploded and the warehouse burnt down, and there was like a cat and it was stuck in the warehouse and the cat burnt to death. And then because all the food was gone, I had to eat the cat, and it was like this fucking terrible, you know, catastrophe. And like, I haven't played RimWorld in like 5 years, 3-4 years, but like I always think about it. I always think about RimWorld. So I think that, like, you know, a game doesn't have to, like, have a long... It doesn't have to be playable for thousands and thousands of hours. It just has to, like, captivate you in the small amount of time that you played it for. And, you know, that experience can be... You can fucking think about that years later, or you just keep coming back to, like, that one time, you know, when this thing happened, or, like, I remember that system, or, like, the feeling that I had in this game. Yeah. So I think doing stuff to kind of nurture that that thing happening. You know, where, like, you're walking through a forest and all of the ferns, you know, get jiggled out of the way, and all of the grass gets pressed down as you walk on it, and you set off a bomb, and there's, like, this wind effect, you know, all the prismatoscape shit. You step in water, it makes ripples. All of that stuff can, like, really just suck you in to the world. Because, like, I don't know if you guys have ever been outside, but out here in the bush, we have long grass. I have grass that's, like, up past my knees and shit. And, like, you walk through that, and it just, like... And you can see it doing the shit with the wind, you know? You see the wind lines. Like, that's real. Wind lines are real, you know? If you've ever been outside. And, like, that shit's so satisfying. And, like, running through grass and it all gets splattered down and you look back and there's just, like, trail through the grass. It's just, like, it's real shit. And I think, like, yeah, replicating that. Because it's just satisfying watching it go, you know? Just oddly satisfying. So I think having a lot of those little touches without it impacting the performance of the game too much. Obviously it has some budget, but yeah. I think including Prismatoscape, the life it brings to the world is insane. Didn't realize how much it added life. Yeah, I just love watching, like, when I'm watching your stream, Jed, and you do the dash, and you can see the wind coming off, and, like, you know, doing all the grass and stuff. That's, like, hella satisfying to look at. Or when you attack, and the grass, like, you know. It's good. It's good. There you go, Prismatoscape plugin. $34.99 from the Fab Marketplace. You've heard the customer testimonies. But yeah, great price. Although I am pretty much like with the videos, I'm pretty much teaching people how to make it themselves at this point. Yeah. Anyway, let's raid out. We're gonna raid Crimson. Cat, where's the cat? The cats are all outside at the moment, actually. They're out hunting frogs. Even with the videos, I wouldn't be able to recreate it. You'd be surprised. You'd be surprised. Once you kind of... There's a moment where it just, like, clicks, you know? There's a lot of those kind of click moments. Where, like, you just get it. You just, like, think of a way that you understand it, and it just works. Anyway, first, Crimson. Dank. Alright. Well, thanks everyone for hanging out. We got 2 videos filmed. We got the Decal masking video, and we also got the Niagara Grid2D basics video. I think I might just do a big batch of video filming. So maybe tomorrow, once my voice is recovered, we will do the we'll do the other thing. What's it called? What's the thing that I'm thinking of? Right, the Fluid Sim basics video, where we like move the die around like we were before. And then I'll look at my video list. Maybe we'll keep working on the weather stuff. I don't know. But I really want nachos. So with that, we say goodbye. Goodbye. And to all the YouTube viewers, thank you very much for watching on the YouTube. Look forward to some new videos. Hopefully I'll be posting a new video this week about custom Niagara functions. So look forward to that one. But yeah, goodbye.